it. So now I have first I have to go. Why isn't it here? Yes, thank you. We add this miniature there, and not for children, and allow embedding. Save your ears for okay, did we name it? Yes, we did. Okay, good. Biosemiotics2021.Day3. Then I go here and I will have an embed code here. And I will copy that. Copy and I will chat it to you or to someone else. You want it?
And I would like to carry this. Thanks. So now I hope I will succeed in embedding. We will try that.
Yeah, you can try and you can share screen and we can see. But I don't. You saw you can drag in. And do you remember the pixel size?
Not at all.
No.
It was maybe I just called Claudio.
Yeah, if he is around, because he had those. Because otherwise it's a too small frame. Yeah, do that. This is taking too long. Det här verkar inte alls, den har inte alls den snabbheten som den står att den har, utan den tankar ner från, den är superlång, så lång som hastighet.
Jag ser inte det mycket.
Nej, och sen när jag tittar på här så ser du att det är liksom 3 timmar, 55 minuter. Och det är ändå, jag hade testat bredbandskollen. Så det måste vara mer av det här.
Okay.
Något annat in the background. Han är förskräckt.
Precis. Men alltså jag trodde det skulle regna rätt mycket i natt. Hade jag stått in.
Ja, men det har man gjort på vissa ställen.
Så även idag. Ja.
Det var knasigt. Maybe we could try another. Vad är det för låt? Try another. I think it's Joni Mitchell. Try another. Den måste spelas nu. I Try another. Try another.
The problem is that Claudia doesn't answer this one because it's probably spike.
Okay.
But is it a big issue if we keep the dimensions like that?
Yeah.
Dimensions.
No, that could, he can change that later. And you can also, if you go, I mean, it should be already the size that we did, because we saved that yesterday.
Oh, so then
I think it, why should it go back to?
It's a little smaller.
Well, yeah, it is. Yeah, because it's part of the embed information, isn't it? It's part of the code, maybe.
It is.
So then, yeah, I think it's 640, but it should be, he should frame with, if it's 600, Johanna, 640, vad är det om det är 640? 480 va?
Kanske.
Istället för 560 gånger 315. 640.
Eller är det 609 på maten? Då är det inte det.
Nej, just det.
I know, but I made it like this, and it doesn't look so bad.
They can choose. If they see if it's small, yes, they can.
Yes.
It's a choice. Yeah. So use it. I think otherwise 640, 480. No, it's 443. So 69, men det går att göra en 69 men don't bother now. we had other things to do here. For instance, we have to find Joni Mitchell's song Try Another. I don't think it's the låtar visa alla. Try another. Joni. Biosemiotics River. Karaoke the Circle. The Rose's Judgment. remember. Now. Smoken heter den. Ligger den på YouTube. Jogging talk.
Can you switch to gallery view?
No, today we have a speaker view day. We have there is gallery view.
It is gallery.
So, yeah, okay. Maybe you should, is it on your side? Oh. Oh no.
Interestingly, on my computer, all it shows is your view.
Uh-huh.
What Yogi's done.
Okay, but you're muted. Yeah.
Okay, so I should be speaking now. It should switch to me. I mean, of course, this is behind. There is a delay, but let's see if it's actually working with me. It's quite a bit of delay, actually.
Yeah.
Okay, so I've been on this for a while, so let's just see what happens here. Okay, there's me.
Oh, excellent. Okay.
It's good to be safe. Yep.
Hi.
Good morning.
Morning.
Kalevi, are you enjoying yourself out in the country, I guess? Are you on vacation?
This is west coast of Estonia, and here I can show you.
Yes.
That's Jakob von Uexküll's former cottage, now biological station.
Now a biological station. Oh, nice.
Yeah, and so yeah, we are spending here a couple of weeks.
And you have good internet connection.
Yeah, as you see.
Estonia is good for that.
True. Pretty good. 5G.
Oh, great. Don, that's probably my slime mold video that kept the YouTube from being the copyright strike. Yeah.
No, I think that was Yogi's.
It's everything. You can't,
I was thinking it might be the flock of birds.
Well, no, because I changed the screen ratio, and also that wasn't BBC, that was an individual. So I don't think that's it, but the slime mold is BBC, I know.
Daniel already located it, and he's going to pixelate it or blur it in some way,
good,
so that the audio stays the same, but the bot won't recognize it.
I just put it there for decoration because I was talking very long at that slide. So
no, it was wonderful.
I didn't want people to I wanted them to have something interesting to look at while they listen to me.
You're interesting to look at anyway, Tori. So, Lamilla, do you want to put the countdown clock on?
Hi, yes. So let me, 10 minutes?
12.
Okay.
And when when Timo comes in, we need to co-host him. And I need to remember to hit the record button. Everyone enjoyed the music last night?
Yeah, that was interesting. Didn't we have David Rothenberg in New York City too? I mean, not performing, but speaking, presenting.
We may have. We could check the Gatherings booklet and see. Quite possibly.
Well, I would have been the one to have the booklet. I couldn't find it. I couldn't.
I mean, the Gatherings book that Tyler and Silver put together with all of the that was the 11th, right? In Rockefeller Center, Rockefeller University.
Yeah.
2011, yeah. Okay, I'm going to mute and take care of some back end stuff, and I'll see you guys in a little bit.
Oh. Hello, Lexi and Ludmilla. Kalevi. Hello.
Hello, Ron. Nice to see you coming in.
Hello there.
Good to see you. I'm just setting up some stuff on the back end here. Is Ludmilla there now? Oh, Timo. Okay, Timo, let me make you co-host.
Okay.
I don't think you'll need it, but I think it's okay anyway. Hold on. You know what? Daniel didn't make us co-host yet. I don't have that ability yet. Let me write to Daniel immediately. Okay, I'll be back in a minute.
Kuidas on, Timo, seal siis Matsalus olla? Tuled vahepeal meid vaatama või?
Tahate, et tulen või? Võin tulla küll.
No muidugi tule, noh.
Okei. Millal teile sobib?
Kuule, me paistab, oleme siin järgmise nädala täielt. Võib-olla praeguse plaani järgi augusti keskeni.
Ahah, okei.
Nii et järjest, nii et ükskõik. Vaatab, millal sobib. Ühesõnaga, meie poolest on täitsa istume siin.
Ma helistan sulle.
Mis?
Ma helistan sulle.
Helista mulle, jah. Mitte kohe ilmselt.
Jah.
Aga pärast, jah. Teeme nii. Las kuulavad natuke eesti keelt ka siin. Ja võt, jah. Niimoodi.
Okay, Timo, now I'm co-host. I should be able to make you co-host. I'm not sure if you need it or not, but we'll see. I actually don't think you'll need it.
So you will give me a lot of power to silence people and to expel them.
Yes, you are going to be a dictator for 30 minutes.
Very good.
If we can get you co-hosted.
I will use it wisely. I hope.
I know you will. With great responsibility comes great power, or vice versa. Okay, I see you're still not on, so let me go off for a minute. Be right. Okay, Timo. I told him, Timo, he should be doing it pretty soon. He's got yesterday's co-hosts up. I think he'll be all right. Timo, can you share your screen? Or you should all be able to, right?
Ludmila is sharing her screen.
Okay,
So.
Right. Okay, so Daniel, can you make Timo co-host? Timo Moran, Victoria Alexander, Yammer Denison.
Who should be the co-host?
Timo, T-I-M-O.
Timo Moran.
There we go.
And Victoria Alexander.
It's already done.
And Yammer Denison. I think that was from yesterday.
Well. Yeah, they are all already co-hosts.
Yeah.
Yeah, I don't see it on my end, but okay. Okay. So how's our timer looking? I guess we're good. Are we live?
Yeah.
I shall record. Yes, Ludmila.
Yeah, please start recording.
Okay, very good.
So we should go to speaker view pretty soon, aren't we?
Yes. And we're recording and we're live on YouTube. And once again, welcome to our third day of the 21st Annual International Gatherings in Biosemiotics. Daniel from NAV Sweden is ably here helping us as our wonderful co-host. So we'll jump right in. I'll just start today by sharing with you a picture of the live in-person contingent last night, watching the special event, which I hope you all enjoyed. And now, without further ado, I'll hand the sharing privileges over to our good friend Timo Moran, who will introduce our first session of talk. Timo, it's yours.
Thank you, Don. And before we start, just a short reminder. So I would hope that our presenters will be in time. I will give some signs when 20 minutes have been passed in video, and if there are like 2 minutes left, when I make some noise. So we'll know that there will be also some time for questions. And also a small request to all the others. So please do not use chat during the talks, but you can, of course, comment after the talk has ended. And also, if you have questions, if you want to comment, raise your hand, preferably on screen by the icon, so I can give you a word for questions. And now to today's session. I think it will be very, very interesting, quite theoretical. We have three speakers, Alexei Sharov, Morten Tønnesen, and Mark Barrault. And Alexei, of course, does not need any introduction. He's a long editor of the journal Biosemiotics and one of grandmasters of biosemiotics altogether. So please, Alexei, the floor is yours.
Thank you, Tim. Good morning, everybody. I want to start with thanking organizers of the conference. Let's see, organizer of the conference, and also thanking for giving me a chance to present my talk today. So I'm struggling to share the screen. I hope you see it now. So my talk is explaining protosemiosis. This is the topic that I have been working for a very long time, but the topic is multifaceted, and that's why I think there's a need to return one more time to it, to show some of the details and to uncover some of the misconceptions. So this topic belongs to the wider topic of levels of thresholds of semiosis, which is one of the key problems in biosemiotics and semiotics in general. So historically, it can be traced back to several dualisms like mechanisms versus human mind in Cartesian view. Then in zoosemiotics, it was the opposition of animal semiosis and human semiosis. And in contemporary biosemiotics, we assume multiple levels or thresholds of semiosis. The lowest level is separating non-living world from life. And among the other forms of semiosis, one of the most fundamental is the distinction between protosemiosis and eusemiosis or true semiosis. Each of the categories has its own sublevels, both protosemiosis and eusemiosis. In particular, one of the sublevel is cognition or consciousness, which belongs to eusemiosis. And there's a lot of misconceptions about this terminology, and some authors argue that bacteria have cognition. One of them is James Shapiro, and there are several other people who defend the cognition in bacteria. I think this is a very unfortunate use of terms. So because each term has a history of its usage, and it would be a mistake to attribute cognition to bacteria. It's much more meaningful to say that bacteria have semiosis. So that's the advantage of biosemiotics, that we have a little bit extended vocabulary compared to those who use very narrow anthropocentric terminology. And it's important to delineate what kind of semiosis can be found in bacteria. So that's exactly what is about protosemiosis. The second important point is that I advocate an empirical approach to levels of semiosis. So semiosis is a part of phenotypes of organisms, and it should be classified using similar principles as we apply to any biological classifications. And we need to consider natural variation within types of semiosis, because as I said, it's multifaceted. There are many features that distinguish levels of semiosis, but some of them are more important than others. It's like in classification of animals, we consider mammals as a class, and this class is characterized by warm-bloodedness, by presence of hair, milk feeding, four-chamber heart, and many other categories. But some of these categories are more important than others. So for example, milk feeding appears to be much more important than others, and it was taken into the name of this class. The same thing with protosemiosis. So there are some more important features that I will try to focus in my talk. So the simple distinction was proposed by Giorgio Prodi, and he distinguished between protosemiosis, which is typical for intracellular signaling, and normal semiosis, which belongs to behavior and communication of organisms. However, this approach is not enough informative for single cell organisms, because in single cell organisms, we have both behavior and metabolism occurring almost on the same organization levels. That's why me and Tommy Verkabara in 2015 published a paper and elaborated this distinction. So we introduced a protosemiosis, which is processing of signals without perception of objects. So this is important, without perception of objects. And eosemiosis is characterized by perception and categorization of objects, which is typical for some functions in eukaryotes. Today, I want to focus on a few further clarifications. First is that inability of certain cells and cell subagents to perceive objects does not imply the absence of objects, both as physical entities and as factors of evolutionary semiogenesis. So what do I mean here? For example, take the chemotaxis of bacteria. So here the object is glucose. So although bacteria has no means to perceive glucose as a molecule with certain structure, nevertheless, glucose is still an object of this sign relation because it is an important factor of evolutionary semiogenesis. The presence of glucose in the environment has a very deep imprint in the organization of bacteria and its genome. This is comparable to what Charles Peirce called the ground of representiment. So Charles Peirce thought that the ground of representiment is an idea of an object, and that is more typical for sign relations, for many sign relations in humans. In short, we still keep the objects are present, but they are not perceived by bacteria. So that's the formula that I use right now. A second, protosemiotic agents such as bacteria do interact with external objects and receive signals of their presence, but they do not perceive external reality as objects. So a few slides I will show that demonstrate organization of bacterial sensing systems. So you know some details. So on the left, you see chemotaxis, where there are chemoreceptors on the very left. The signal originates from binding of chemicals to chemoreceptors. And then this signal is processed through several steps until it reaches the flagellum, which is rotated one direction or another and causes the movement of bacteria. The second example on the right is phototaxis in cyanobacteria. So here, interestingly, the cell functions as a lens that concentrates lights on the other side of the cell where photoreceptors are located, and they detect light. Then the signaling of these bacteria is organized so that the bacteria moves in the towards the light, towards the incoming light signals. And the third example is a magnetotaxis, which is also a distal sensing. However, it is magnetosome so it's a string of ferromagnetic crystals that are grown inside of bacteria. And it is not a true sensor in this as we understand it, because it doesn't generate any signal. Instead, it is a passive body orientation tool. So simply the bacterial cell is oriented, becomes oriented along the lines of magnetic field. Interestingly, magnetotaxis is often combined with chemotaxis. And this scheme shows that bacteria are oriented along the geomagnetic field shown by green lines here. So the green arrows, and it's different in northern hemisphere. It goes from the top down, whereas in southern hemispheres goes from the bottom up. And bacteria are oriented respectively. However, the chemotaxis is detecting oxygen and sulfur gradients, and it causes the flagellum to rotate either clockwise or counterclockwise, and that determines the direction of movement of bacteria. And these mechanisms, interpretation mechanisms, results in concentration of bacteria in so-called oxic and anoxic transition zone, which is most favorable for the metabolism of these chemosynthetic bacteria. And finally, I want to show you some appendages of bacteria. So bacteria is not just smooth on the outside. It has lots of appendages, not only the flagellum, but also fimbriae, pili, and also there are some discussions about bacterial nanotubes, but the nanotubes are not confirmed well enough, so it's not clear their function. So in short, flagella are used for locomotion, sensing. Pili are not rotating, but they are and used for selective adhesion, immune functions, invasion of hosts, secretion, sensing, pooling, and DNA transport. Fimbriae are very short and narrow appendages which are used for adhesion, immune, and invasion. So this shows that bacteria indeed interact, has organs of remote sensing with outside objects. However, the result of this interaction is again a single signal which is sent to the cell for processing. So it's some kind of signaling molecule that doesn't carry any information about the nature of the object with which bacteria is interacting. So to characterize the nature of protosemiosis, me and Morten Tonneson developed diagrams in our book that hopefully soon will be published on semiotic agency. So this is the diagram from that book. So here, bacteria live in so-called signal world. It's not Umwelt, but signal world is different because signals are processed individually, and the object is outside of the perceived world. It belongs to Umgebung. The same thing is movement. Movement is not perceived or intended by bacteria. Bacteria simply rotate the flagellum, and that's it. However, it has habits, sensing, associating, or rotation habits, which have emerged during evolution. In contrast, the eosemiotic sign relation is much more complex. It includes Umwelt, Innenwelt. So Innenwelt is internal model of the outside world, and Umwelt is a link between real objects and functions assigned to that objects by the animal. The processing of the sign includes many steps. What is important here, there is a recognition step where the pattern of signals is recognized. The sensing is different than in protosemiosis because it's very signal rich. So instead of one signal, there's a large number of signals that form a pattern, and these patterns are recognized and associated with external objects. So this is a table of comparison. So in protosemiosis, we have singles are processed either directly or via simple logical gates, whereas in eosemiosis, rich sensory input is filtered by cascades of signaling networks. In protosemiosis, no reality is assumed as a source of receptor excitation, no notion of causation. Whereas in eosemiosis, the pattern of excitations is interpreted as a representation of objects in the outer world. In protosemiosis, no association between features of the same object or related objects. For example, the same glucose, the presence of glucose is detected by one type of receptor. The absence of glucose is detected by completely different receptors and processed differently. Whereas in eosemiosis, they are connected. The features are connected. In protosemiosis is threshold-based processing, whereas in eosemiosis, sensorial patterns are linked to individual objects and recognized as instances instances of specific categories. There's categorization. And finally, in protosemiosis, no internal space-time model of the world, whereas in eosemiosis, objects are placed into the time-space model of the world. Both protosemiosis and eosemiosis have several subcategories or sub-levels of semiotic. I will not read them, just show briefly. In particular, eosemiosis has the several levels of cognition categories. And I'm going to conclusion that among multiple thresholds, the level of semiosis, the most fundamental appears to be the difference between intracellular protosemiosis and eosemiosis in more complex life, starting from eukaryotic cells, where protosemiosis still persists at the lower level of signaling. Protosemiosis is non-representational and organized as signal processing, where abstract signal tokens are associated with action tokens, either directly or via simple logical gates. Protosemiotic agents such as bacteria can sense objects, interact with them, but they do not understand that they deal with external objects. And finally, eosemiosis is the minimal mind, where objects are perceived, tracked, categorized, and placed within the internal space-time model of the world. Thank you.
Thank you, Alexei. We have about 8 minutes for questions. Kalevi, please.
Great, thanks. So this topic is really so very, very important, and every small step here for new step in understanding is important. I very much like your emphasis on empirical approach here, because that's probably the only one via which we can really solve these problems. But here, just a little, well, two-side question now. First, say these features we need to just describe here are obviously functional. And now I have probably several times proposed to use one of features here, the type of learning, so that in this very most primitive type of semiosis, we could connect it to the imprinting as the most simple type of learning. And why you do not use that, so because every interpretant is making or just like connected to learn. The other side is that why do you not accept the light, perception of light as perception of object? Because once the bacterium can make a distinction between two different types of signals, or then it already has information about the object. So therefore, light, perception of light can be a perception of object. Thank you.
Okay, so first about learning. So learning appears here. So learning belongs to eusemiosis, and even not to the first level of eusemiosis, but starting from the second, learning-based object recognition and manipulation, whereas innate-based object recognition and manipulation is minimal mind, but without learning. Learning is a difficult category again, so it's multifaceted category. And in some researchers consider non-associative learning, which is habituation and sensitization. However, habituation and sensitizations are present in all domains of life, so it's not informative for distinguishing levels of semiosis in life that we know on Earth. And that's why I think we should exclude non-associative learning from the learning category. So it's not real learning, it's simply sensitization and saturation. Then the second is perception of light, why it is not an object. What is important is that the perceptual input is much more poor than the information about the objects. That's the main thing. So when we associate an object with the perceptual input, we gain some additional information. That's the main thing that is important for person-sign relation. In protosemiosis, there is no additional information. So the bacteria gets light, and that's the only thing that it gets. So it doesn't know the source of the light. It doesn't know what stands for this light. It only knows that the light is coming, light versus dark.
Thank you. Tori Alexander, please.
Hi. Yeah, I'll say this. I mean, this is the kind of thing that I say often, but I'll say it again. We have no ability to perceive God, and yet we have many signs that stand for that object. So we're like bacteria, I guess, in the face of God. If we want a theory of semiosis that applies to all living organisms, then we can say that an object is neither a thing or an idea, but a reinforcing effect on that response to the sign vehicle. In all semiosis, there is no actual connection with the object. All experiences are mediated through signs.
So I agree that all our experiences mediated through signs, but in eusemiosis there is so it's representational semiosis. So that means that we see a more, so we project a more rich reality based on the sensorial input that we acquire. So although we do not see something beyond the sensorial input, but we have some historical a record of previous interactions with the same objects. So the idea of sameness is exactly what I mean by object categorization. So, and that allows eosemiotic agents to accumulate experience about each type of objects. And these objects can be real, like physical objects around us, or they can be imaginable objects. That doesn't matter. It's still experience that associated with objects in general, which is not fully represented in each individual interaction.
Thank you. I would give a last question to James Rose, and let us keep all the other discussion to the breakup room. So James, please.
Okay, thank you.
You are muted, we cannot hear you.
I have a slow computer. Thank you. Your comment now about the repetition being a supporting factor is very important. Just as a sidebar, in 1890, Thomas Edison was interviewed, and even he back over 100 years ago mentioned that atoms are consciousness, which became a surprising thing. But it seems to me as a biologist that memory is an important factor. And I'm wondering if I came to an understanding that possibly our definition of memory is biased towards the factor that you remember of re-experience. So that in the definition of expanding in order to find a way to segue and link the non-living to the living world, that maybe memory exists in a slightly different format than what we are used to, where we separate hardware from software, where information is retained within the hardware. So I was wondering if you might comment on the notion that memory in the essential aspects of structure of the universe and atoms and such memory is in the laws of nature. So there's repetition and consistency and repeatability because it's not operating in the sentient human semiotic notion of meaning, but in terms of performance, that the reliability and quote unquote memory of how to do and what to do, the notion of the responsiveness with meaningful reaction with the world is not really the criteria, just the fact that there is the notion of persistence of reliability of interactions, and that is another form of memory, a more essential form. Your thoughts?
Thank you, Jamie. This question is indeed very important, and it's hard to give an exhaustive answer to it, but I will give you a few hints. It's important to distinguish between potential meanings and actual meanings, or potential signs and actual signs. So any correlation in nature, like cause relation in nature, for example, asteroids falling on the moon and making craters. So the craters are signs, potential signs of comets and asteroids. However, these potential signs do not perceived by observers. So unless they are perceived by competent observers, they remain potential signs because they do not function as signs in the semiotic sense. But I think that it is important to bring some of the potential signs into semiotic as well, at least to some extent. So it is not that I'm advocating pansemiosis. So I'm trying to walk a very narrow line here between pansemiosis and real semiosis. So I acknowledge that we need to consider also potential signs, because For example, if the environment is not rich enough in potential signs, that no agency will be able to exist there, because there is no correlations. It will be just chaos and no possibility to establish any functional relations. So it has a meaning for biosemiosis, but it still needs a little bit more better terminology. I would not call it memory. So, but potential science could be a good term for that.
Thank you very much.
Thank you. Let us now give floor to our next speaker, who is Morten Tønnesen from Norway, and his talk will connect Uxkull theory and phenomenology. So please, Morten.
Just a moment, I stop sharing. How to stop sharing?
I think you stopped now.
Yeah, yeah.
Let me see. Are you seeing the wrong screen now, or what seems to be the presentation?
We are seeing your presentation, so everything is okay.
Presentation mode, great.
Yes.
And it changes slides now, does it? No, wait. Here it does, right? Second slide.
Yes.
Okay, then I'm ready to start. So I'm going to talk about phenomenology, and more specifically about how umwelt theory can contribute to phenomenology, and how we should understand phenomenology in light of and by also using umwelt theory. This presentation is based on 2 book chapters that have been written but have not yet been published. So one of them is called Phenomenology, and it's from the book that I am co-writing with Alexei. And I will also make use of a few figures from this book in the course of this presentation. And the other chapter that this presentation draws on is titled Umwelt Theory for Practitioners, Semiotic Guidelines for Application in a More Than Human Descriptive Phenomenology, which will appear in the anthology Open Semiotics. So I'll start out with a more theoretical part and end with a more applied or practical part. And a main point for the first chapter on phenomenology is to make the case that phenomenology as a theory and as a method needs a biosemiotic grounding. And so I will, in this presentation, make some comments about some classical and some contemporary views within phenomenology, and try to explain how I think biosemiotics and umwelt theory can offer a relevant framing for phenomenology, and also help resolving some disputed issues within phenomenology. Here you also see the keywords subjectivity and sentience and consciousness and self-consciousness. And I will not explore those systematically in this presentation, but these are covered in the chapter text. But you see a progression there from something more universal to something more particular, starting with subjectivity. And as biosemioticians, we are used to refer to any organisms as subjective in one sense. And then a lot of biosemiotics is about exploring the different kinds of subjectivity among organisms. And at some point, of course, sentience shows up for sentient organisms. And then some would say that's the same threshold as for consciousness. And then a new threshold is reached when we talk about self-consciousness. So what I will relate to here is, first of all, different phenomenological understandings of what it means to study consciousness and to distinguish between human and animal experience. And a main motivation for my work with phenomenology is to contribute to going beyond a quite anthropocentric phenomenological tradition. And it's a bit puzzling in a way that contemporary phenomenology is as anthropocentric as it is, because even some of the classics within phenomenology acknowledged that there are animal subjective life worlds as well. Both Husserl and Heidegger explicitly refers to the existence of animal life worlds, but they partly and especially Heidegger does it to contrast it with the human life world, the human existence or Dasein. This is most clearly expressed when Heidegger discusses the work of Jakob von Uexküll and his Umwelttheory, but uses it as a contrast to his understanding of the human life world and characterizes animals as poor in world. So what he says, Heidegger, is that animals have some kind of access to the world and implicitly some kind of life world, but he underlines how that life world is radically different from the human life world and how human beings have a unique access to the world by having what we could call a reflective self-consciousness. I will not spend so much time talking about the Lebenswelt notion of Husserl, but I've noted in previous work that there is an overlap between the Lebenswelt notion as developed by Husserl and the Umwelt notion. But what I suggest is to use Umwelt theory more positively in further refining and developing phenomenology, because I think Umwelt theory offers a more pluralistic and comprehensive framework for phenomenology. And what it obviously can provide is a phenomenology or aspects of a perspective of a phenomenology that goes beyond the human to also address human subjective experience. You see Merleau-Ponty mentioned here as well, and it's noteworthy that both Heidegger and Merleau-Ponty discusses Uexküll's work explicitly, and Merleau-Ponty also has a more positive expressed attitude to the Umwelt theory, and he is also closer maybe to a biosemiotic understanding of phenomenology by being much more open to empirical science and natural science. One key problem really in contemporary phenomenology is delimiting or defining the range of the study of phenomenology. If we look at one of the mainstream definitions of phenomenology from Stanford Encyclopedia of Philosophy's article about phenomenology, we can define phenomenology as the study of structures of consciousness as experienced from the first-person point of view. That's how that presentation or article on phenomenology starts. But if you just look at that exact definition, it's kind of puzzling why most phenomenologists work only with human phenomena. Because as natural scientists and informed people would agree that a lot of animals also are conscious and have a first-person point of view. So why are not that topic matter treated equally or given proper emphasis in phenomenology? And part of the reason for that is that implicitly most contemporary phenomenologists doesn't really operate with this broader definition of phenomenology, but they would add that for consciousness to be of interest for phenomenological studies, it should involve reflective consciousness. And some phenomenologists would acknowledge that some animal species have reflective experience as well, but this is disputed. And quite a few phenomenologists would think that only human beings have a proper reflective consciousness, and therefore they only study human experience and human consciousness. But I think that even this literal broad definition of phenomenology as the study of structures of consciousness as experienced from the first person point of view shows that there should really be an opening for having a wider, more comprehensive conception of phenomenology. And that would also help align phenomenology as a theory and as a practice with cognitive science and contemporary empirical science more broadly. So now I get to some of the figures I'll show from the book that Alexei and I have written, and that is soon to be published. And I'm just showing here a figure involving protosemiosis and eusemiosis, just to make the point that in our conception, we need different distinctions between different kinds of signs and semiosis. And this also reflects an understanding that there are life worlds of a semiotic and phenomenal nature that are very different in nature. So there are some organisms that only engage in protosemiosis, that have a kind of non-representational life worlds that we also refer to as signal worlds. And then there are animals with much more complex and also with representational life worlds involving objects. Here's another figure showing some of the big picture of different kinds of semiosis and different realms where we can say that semiotic agency is involved. And if you read vertically under representation, you see that we have marked a portion of this as with perception and phenomenology. And we refer them to phytosemiosis, zoosemiosis, social and cultural semiosis. And if you look to the left, you see that the kind of agency involved has to do with organism level agency or groups of organisms in form of families, colonies, organizations, cultures. So basically we regard phenomena and the study of phenomena as related to organism level semiosis. So semiosis that somehow involves the organism as a totality, as a whole, either individually or socially in a social setting. And it's also related to sociality and to behavior. These figures were shown by Alexei as well, and shows on top a signal world, which is what you have where there is only protosemiosis at work. And here we use the Uexkülian notion of the Umgebung, the material, physical surroundings, which here is also called the non-perceived world, but involving objects that we can, as researchers, observe that some organisms engage with, even though they do not perceive these objects. And at the bottom, you see the better known Umwelt, where we can distinguish not only between the Umwelt of an organism, which is experienced by the organism, and that involves objects. So we can not only distinguish between the Umwelt and the Umgebung, but also see this distinction between the Umwelt and the Innenwelt, because the Innenwelt only appears where there is an Umwelt, which is why we don't speak about Innenwelten in the case of organisms that engage only in proto-semiosis. So this distinction between the inner and the outer world is only a topic for organisms endowed with an Umwelt. Here's the final figure I'll show from the book Semiotic Agency. And it contrasts a biosemiotic understanding with a simplistic phenomenological understanding of the complexity of different phenomena. Because the most simplistic phenomenologists would say that there are only human phenomena. And this is what you see represented by the line that shows up from nowhere and represents human phenomena. And it's hard, at least in evolutionary terms, to explain how there can be human phenomena at all if you think there's nothing that precedes it. And the dotted line here that is starts from the 0 point and then goes up to human phenomena represents the variation of different kinds of phenomena at different complexities. And you also see indicated by this figure that we think that generally phenomenal complexity corresponds to biological complexity, so that the clear tendency is that the more biologically complex organisms also experience phenomena with a greater complexity. So that's a more gradualist view and a more pluralistic view. And we think it is also better able to explain how there can be human phenomena at all. Now I'll make a couple more theoretical observations. And one concerns what is called naturalized phenomenology, because in our times, many phenomenologists call for naturalizing phenomenology by aligning somehow phenomenology with the empirical sciences. And while that might make good sense for us today, it contrasts with some of the original thoughts of phenomenology in its classical versions, where phenomenology was contrasted with naturalism and opposed to it. So this has to do with developing phenomenology further, and it also means developing a kind of phenomenology that differs from, for instance, Husserl's phenomenology in some of its most known classical versions. And that's also because Husserl emphasized that we should study the phenomena in themselves without trying to relate them to our knowledge about how they might relate to empirical reality. But from a biosemiotic standpoint, it seems more fruitful to also to contextualize study of phenomena in consciousness and elsewhere with other knowledge that we have about biology and cognition and so on. You also see Peirce mentioned here, and of course many would hold Peirce as their favorite phenomenologists since he conceptualized phenomenology, sometimes called phaneroscopy, and has an alternative framing of phenomenology, which was developed around the same time as Husserl's conception. But on this point, Husserl and Peirce are quite similar, because they both stress that we should study phenomena in isolation from the broader empirical reality, which is not a very good starting point for a biosemiotic approach to phenomenology, where we try to make use of empirical knowledge. And And as I already mentioned, Merleau-Ponty comes out in a bit better light in this context because he had a more positive and proactive relation to empirical sciences. A final theoretical point, and this is just to mention really some of the basic perspectives of Husserl and Peirce. They both theorized on both phenomenology and on semiotics. So it's that their work and texts allow us to try to see how they looked at science and phenomena in context. And while the difference between them really fundamentally is that Husserl thought that the occurrence of science relies on conscious subjectivity, and that conscious subjectivity is what is primary. So he had a higher threshold for science, and that reflected in some cognitive semioticians' take on phenomenology. For instance, Göran Sønnesen, who says that there's a lot of meaning that is not represented by science. And that would be the Husserlian approach, whereas Peirce rather thought that signs are primary, and that conscious subjectivity relies on science. And that's also why Peirce has a much lower threshold for what he conceptualizes as a sign. I'll have to wrap out soon, so I'll stop by some of these practical considerations of how we can make use of an applied Umwelt theory in a kind of phenomenological studies. And this brings us over to the second text that I'm presenting some of here. And here we're faced with the notion of descriptive phenomenology, which is practiced today. So we can distinguish between phenomenology as a theory, as some philosophers prefer to approach it, and phenomenology as a method or a practice. And descriptive phenomenology is the practice of mapping and describing and understanding life worlds. But this is almost exclusively done with a mind to studying human phenomena. This has to do with the anthropocentric bias in the phenomenological tradition. The problem really is that there's not much methodology developed or in use explicitly as part of the practice of phenomenology related to studying non-human experience. So the question here.
2 minutes.
Thank you. The question here is how we can, what methods we can use to study also animal life worlds. And I think that's easiest in settings where we can also observe human-animal interaction. In contemporary descriptive phenomenology, the usual methods are usually related to conducting verbal interviews, maybe transcribing them, and also studying written accounts. Whereas to go to include non-human phenomena, it makes sense to use participatory observation and also interaction and observation of one's own interaction with animals, and also supplementing these methods with expert interviews. So this is how I think that we can quite easily and with quite known methods make use of Umwelt theory in a sort of more than human descriptive phenomenology. And what I have done in this second chapter is to try to provide some very simple guidelines for applying Umwelt theory. So it requires some knowledge about phenomenology, some knowledge about Umwelt theory, and then you could follow these guidelines in study of animal and human Umwelts interacting. So it requires some foreknowledge, and then trying to identify, typical actions and Umwelt objects for the animal that is studied, and to observe how the animal interacts with its environment and also with humans involved, including the researcher. And then summarizing participant observations in light of the foreknowledge and trying to combine literary studies or research literature with some field work and some of these applied methods. And I'll just mention that I've also then tried to have in mind different kinds of professions, especially veterinarians, ethologists, and zookeepers, but also more generally, anthropologists and social scientists that study human-animal interaction. And I think it's doable to try to make use of some Umwelt theory in this expanded descriptive phenomenology that allows us to also study human phenomena. And that's where I'll end.
Thank you, Morten. I very much liked your practical methodological suggestions. Philip has a question, and then Maurita, and then we are out of time. So Philip, please.
Hello, Morten. I am also a big fan of interactions between phenomenology and biosemiotics. What I was missing a bit in your presentation was mentioning enactivism, because it seems that there are many phenomenologists who now interact with this field. And it's also about like merging phenomenology and let's say continuous view of cognitions throughout life. So for example, even Thompson, my question would be, what would you propose as a biosemiotician to phenomenologists to merge rather with us biosemioticians than to its enactivists?
Well, I mean, I've addressed this topic as well, like the resemblances and differences between biosemiotics and enactivism in relation to the view on organismic agency, for instance. So of course, part of the agenda is similar, but I think some of the advantages with a biosemiotic perspective is that you operate with a threshold for both science and phenomena that I'm more comfortable with. But of course, there are exciting things that can happen in interchange between biosemiotics and activism as well.
Thank you, Morten. Maurita, please.
Thank you. Thanks, Morten. I really enjoyed your paper and really looking forward to reading your book. So I hope it comes out soon. Look, a couple of things. The opposition to science that we found in Husserl, and not so much Merleau-Ponty, was, as I see, was really an opposition to scientism or reductionist science. Certainly Merleau-Ponty was not anti-science. He drew on it frequently. And also with the, I wanted to put up a bit of a defense of Merleau-Ponty, who I sort of separate out from the other key figures of traditional phenomenology. But we find in his work that the Umwelt, Uschkul's Umwelt, is a theme. It keeps cropping up from his very early works right through to the later ones. And to me, that establishes a continuity between his earlier and his later works. And incidentally, he doesn't talk much about consciousness. He talks about intentionality, but it's embodied intentionality. And I see as intentionality applicable to all living things. But what this leads him to in his later works, and sadly he died before he wrote them up, but what he's heading for, it seems to be, is a reconceptualization of nature, a philosophy of nature, rather than what we see as phenomenology, as the first person perspective. So to that extent, I want to defend Merleau-Ponty or suggest that he is someone for whom the biosemiotic, the non-reductionist biology of biosemiotics does fit very neatly.
Yeah, thanks for that comment. I also think that there are very clear commonalities between a biosemiotic perspective and some of the work of Merleau-Ponty, and also maybe in attempting to go beyond consciousness, since if we acknowledge that there are very different kinds of life worlds, then we could also acknowledge that some of them are sentient and conscious, and some are not, when we talk about the subjectivity and agency of non-conscious organisms. So I think that biosemiotics is well positioned to address the full diversity really of different life worlds within and beyond consciousness.
Thank you, Morten. Let us move now to our third speaker, Mark Barrow. And his talk will be about causality, information, and semiosis. So please, Mark, floor is yours.
Okay. There we go. Just reduce this. So yes, in this presentation, I'm going to be looking at the incongruence that lies at the heart of concepts of causation and information, which of course are central to semiotic studies. I'll start by critiquing them, and then I'll be presenting what I consider to be a more coherent framework, which I will then at the end relate to species, consciousness, institutions, cultures, and ecologies. So yes, the presentation is based on a paper that was published in Biosemiotics Journal in 2020. And there's the link to it, which I'll be providing at the end if anybody wants further reading on this. Now, to be honest, actually, I was up very early this morning thinking, what is it do I not like about the slide for my page 3? And something occurred to me that it was reminiscent of the problem was reminiscent of a paper that I submitted to a journal, and I received feedback for it, which one of the referees said, I don't like the phrase gives rise to, because it hides a lot of what is claimed to be explained. So quite a lot of my illustration had arrows in it. And I was thinking that these arrows were presenting somewhat of a problem to me. The beauty of an arrow is that it can point up or down, left or right. And it is often used as an indicator of spatial direction, temporal direction. It might indicate simplicity to complexity, and it might also indicate process. And this got me thinking about what Nora Bateson was saying about the hidden meaning of things, and that the arrow was a kind of transitional concept which wasn't functioning very well in the illustration that I had, so I decided to delete it. And so I thought I'd start with something fairly uncontroversial and just say, well, stuff happens. And we have an arrow pointing at it because we think, well, what is it about stuff that makes it happen? We might say stuff happens because it's caused to happen. And often we think of cause as being something that existed before the thing that happened. And that we also think of the cause as something that is in proximity to something that's happened. So the arrow here infers a temporal and spatial aspect that instantiates some privileged secret power over things. But then we might say, well, what is this secret power? And I think the term information is often used as a filler for this mysterious causal power. And in this regard, the arrow suddenly has an informational role to it. whoops, I'm not getting the, okay, here we go, meaning. But of course, information is inextricably linked to the notion of meaning. But then what can we say that is that stuff happening? What can we say about meaning in terms of something happening as having meaning or not? So typically we might think of a biological thing as having meaning, whereas an inanimate physical process is not having meaning. So in order to get around this sort of difference, we might think, oh, well, this arrow needs some kind of sense of agency to it. The agency is that which creates the meaning, and it uses information to do that, and it causes something to happen. And so our arrow has developed even more value to it, if you like. And some people might just say, well, actually, it's just the microphysical that makes stuff happening. Microphysical makes macrophysical things happen, smaller to the larger, sort of reductive sense to things. So what we tend to do is we tend to use a term, whichever term is convenient for us to say is applicable at the time of saying, in order to explain the stuff that happens. And this, in a way, is where I get this relation to the phrase gives rise to. Our arrow has developed multiple meanings. So much so that quite often the arrows are pointing every direction. There are many examples where you can think of agency causing meaning, meaning affecting agency. And I suppose that's possibly why my favorite arrow of all, the bendy arrow, is quite a useful tool, because it implies a sort of feedback, circularity, which allows these concepts to circulate themselves. Now I'll put a green circle around this because it's a bit of a mess, really. But my view is that biosemioticians in the heart know that there's a bit of a mess here, but I think they have an intuitive feel for the idea that sense can be made out of all of this. The trouble is for biosemiotics is that it's kind of inherited a lot of these terms. And they kind of need unpicking, really. A sense of the problem of the arrow for the biosemiotician is what I want to talk about now. So we can start from the idea that there is meaningful action. When we look at the biological, we invariably see action as meaningful. Meaningful action is what we want to understand. It is what we want to explain within the wider context of environment. Now, the interpretant is, in a way, the moderator of meaningful action. Without the interpretant, there would be no meaningful action. And in this way, we could say that our little red arrow indicates a causal relation that the interpretant causes meaningful action. But then we have to introduce the idea of agent as the meaning maker. And how is the agent the meaning maker? Well, typically we think of it as selecting, reading, deciphering, and decoding information which flows in from the environment. So again, we've created a little arrow there, an explanatory arrow, for the sense that agency requires information to flow from the external. But then we start ending up with a bit of a problem, because information is typically got the sense about it to have intrinsic meaning built into it. Invariably, information is given a quantitative property. It is often regarded in a substantive commodity kind of way. Often it's thought of as qualitative, temporal, and even spatial. So for example, DNA, it's often spoken of as information in code that can be decoded. And when it's decoded and reconstructed or reconfigured, it creates a three-dimensional creature with all the process that's required for it to survive. Similarly, another example is if an electromagnetic wave hits the back of the retina and a neuron fires, the cognitive scientists will say, well, there's the information that it's going to process. So somehow this neural signal has become informational of the external environment. And in that way, the information has explicit meaning before it's even entered the brain, but the brain somehow processes that information. And lastly, a book. If I hold up a book and say, what's in this book? You might say, well, I've not read it actually. But you could well say, well, there's information in that book. But again, it's just pages with black markings in it. So what I'm trying to point out here is that there's an equivocation between agency, meaning, information, and causal power. And that is what I meant earlier by all those arrows pointing in every direction. One broad conceptual solution to this is to say that there's a cascading causal feedback of events that instantiate meaningful action, and that this might be understood as a dynamic scaffolding where meaning evolves, but it does not indicate why meaning in its various forms has the character that it has. And it doesn't give a sense of agency's origins as a meaning maker with its own causal efficacy. In fact, the only way to really add these to the illustration is with some arrows. So my view is that an agent identifies signifying elements on account of their meaningful relevance. So an agent cannot identify a signifying element that is not meaningful to it already. From that position, it can attribute informational, digitized, or categorical properties to those signifying elements, depending on its levels of sophistication. Its Umwelt is thereby represented informationally as a refinement of an infinite array of possible meanings. Subsequently, meaningful action, depending on the kind of agent we're talking about, can be merely reactive, or it could be adaptive, experiential, or even conceptual. And the nature of the coherence of that action substantiates the unique physical ontology that exists between the agent and its environment. So there's an awful lot to unpick in these ideas, but if we return to bullet point A, you might immediately question the fact that signifying elements are selected for by their pre-existing signification. And this is to say that an agent's meaningful actions are determined solely by its pre-existing construct. So in order to address that query, I'm going to talk about what I mean by construct. But before I do that, I'm just going to, in one slide, talk about point D in terms of the different classes of agents. Because I published a paper on the different classes of agents, effectively, in 2018 with Biosemiotics Journal again. Now, the idea is that there are ontologically distinct agential categories with distinctive classes of meaningful interactive action. So there's a kind of hierarchical layer to be considered here. But I'm going to move now on to explaining what I mean by the construct. And in doing so, I'm going to call upon Newton's first law of motion which states that an object remains at rest or continues to move at a constant velocity unless acted upon by force. So typically when we think of Newton's first law, we imagine two spheres floating in space, traveling towards each other on a collision course. If we were to stand on object A, we might perceive that we are traveling towards object B, or we might perceive that object B is traveling towards us. Conversely, if we stand on object B, we might perceive that we're traveling towards object A, or we might perceive that object A is traveling towards us. Ultimately, there is a collision. And what can we say is the cause of the change that took place? Which object is responsible? Does A cause B to change its motion, or does B cause A to change its motion? Similarly, does A give information to B that tells B how much and in what direction to move, courtesy of its mass and velocity? Or does B give information to A, telling A how to move? My way of seeing it is that objects A and B have formed a dynamic coupling or construct. This is expressed as a newly negotiated equilibrium. So a process of connectivity or mutual becoming with the opposing object of interaction is what is indicated by this. Now, in that visualization, the objects that we're viewing were spheres, hard spheres traveling through space. And now I want you to imagine them as non-solid, but still coherent unitary constructs. So we can think of the Newtonian object or sphere as lacking clear spatial or temporal boundaries. In their place, we can think of them as being more dynamic and fluid, but coherent unitary constructs nonetheless. So examples of unitary constructs are species, institutions, cultures, ecosystems, phenomenal consciousness, an atom. I'll put an exclamation there because I wanted to put in something that is physical and that might not be typically regarded as having agency. But the hierarchy that I mentioned does indicate that the physical does have meaning. All action is meaningful, and that applies to the physical as well. And then there's the living self, for example. And I mean, there are countless examples. I just picked those out as being possibly interesting to talk about. And the other sphere that with which it collides with is any disparate influence, and that could be the internal or the external environment. Okay. So if we look at a species, it can be understood as an example of a coherent unitary construct. Species do not have clear spatial and temporal boundaries. They're made up of lots of individuals going about their daily business. That's possibly why it's very difficult to categorize exactly where these boundaries lie. Now, the important point here is that disparate influences are not the cause of adaptation, nor do they inform the character of meaningful adaptation. The meaningful adaptations that do evolve will facilitate beneficial responses to the disparate influences of the environment. So there is a connection there, but it is not of the kind that physics or biology would have us believe to be the case if one just looks at cause and information in the way it's typically viewed. Now, institutions are similar in my view, but they have a much more formal structure and more regimented boundaries, if you like, with the individuals that might be employed in it and the buildings in which they work. And the disparate influences, again, do not cause institutional activity, and they don't contain the information that informs institutional activity. It's rather the rules and regulations that might have been drafted by the board members and the facilitators that work there that enact the actions of the institution, and they both respond to the disparate influences of the external environment, but also the internal operations of, you know, the way the employees discuss matters about, you know, institutional activity and so forth. So it has clear internal influences that affect the meaningful behaviours that the institution then activates as part of its remit. I put down cultures because of the incredibly difficult sense of its spatial and temporal identity. But I do consider cultures to be a coherent unitary construct. A culture can be thought of as a Newtonian body that responds over generations to its interactions with disparate internal and external influences. Now, these influences do not qualify the meaningful properties that one might associate with the cultures that exist. So there's a very clear distinction between the disparate influences and the meaningful activities of a shared culture. And we have an ecosystem, another very disparate construct, if you like. Unlike the culture, it doesn't have shared beliefs. You know, well, perhaps one could think that they do, but I haven't really thought about that. But the instrument of its making is a responsive, dynamic balance for whom many of its actors have an invested interest, and much of the disparate elements are from within, but obviously from without as well. And once again, the point that I really want to emphasize is that the disparate influences aren't the cause and do not inform the nature of the activity of the construct itself. And the last example that I've provided is consciousness. As conscious creatures, we have a sense of its temporal and qualitative nature, of course. So consciousness very much feels like a unitary whole. At the same time, it's very difficult to place it. You know, you can't get a knitting needle and say, this is where it is in the brain that consciousness resides. And the sense of its presence, in a past and a future is also quite difficult to get your head around, because as soon as you examine it, it's the examinations in the past. And we often think of our brain as a processor of information obtained from the environment, but it isn't. It is the construct of our physiology and experiences that qualifies the ontological realm of our meaningful relation to the world. So it is this meaningful relation that we only then categorize as information bearing after the event.
2 minutes.
Yep, just to summarize, meaning in all its ontologically distinct incantations determines the nature of all action. That's physical, biological, and mental. Unified constructs designate particular classes of signification to disparate influences. Information is an agent's formal or categorical attribution to the meaningful relation it has with the world. What I want to emphasize is information is often thought as the transmissible medium of causal determinism, that it has some kind of mystical power to it in that way. And it's also thought as the malleable commodity to meaningful interpretation, codification, and transmission. And this is, in my view, just wrong. Finally, semiosis is the process where unitary constructs categorize objects as sign relations in virtue of their meaningful relevance. And that's the end of my talk. Thank you for listening. That's the link to my paper again, if you are interested in reading further. Any questions?
Thank you a lot. Questions, please, comments? Jakmur.
Mark, I really like very much what you present, and also I enjoy very much how close it is to Simondon's thinking, which I'm trying to present since years. So I don't want to occupy everybody's opportunity to ask questions, but I really strongly recommend to have a look at it. You will recognize yourself how they resemble each other. I just want to point out one resemblance: the coherence in your coherent unitary construct really evokes Simondon's internal resonance, which constitutes the unity and identity of individuals. So, thanks.
Yes, I did. When you gave your talk, I saw a lot of resemblance to what you were saying and the kind of ideas that I wanted to talk about. So I certainly saw resonance there. So.
Okay, I can see Peter Harrias Jones to raise a hand, and then after we need to close the session, but we have a chance to go to breakout room and to continue discussion there. So Peter, please.
Yes, can you hear me?
Yes.
Okay. I wonder whether I'm deeply interested in your paper. I think you've done a brilliant job at naming some of the questions. I'm wondering whether, though, causality is too much in mind and you could not move to anticipation rather than causal sequences, and whether this would make things a little more simple in your diagrams. Information concerns anticipation of repetitive events or non-repetitive events, and recognition here of pattern, which was Bateson's point, as against objects, which we had in the previous discussion from tennis. Any interest in that?
Well, that sense of information in terms of anticipation sounds like it's got meaning in it.
Yes, indeed.
And I think that's part of the issue that I have, is that where you just can't glue meaning onto something if you haven't got the prior explanation to it, having been there in the first place, which is why I come back to the concept of the construct as being informed by all its past, its physiology and so forth in the case of organisms. And therefore they can anticipate because they have that construct, that capability is somehow implied in the nature of the construct, because it is so important to anticipate, to be an agent in this world, to survive as an agent in the world. So yeah, that seems to me like it's just a bendy arrow, what you're saying.
Yes, absolutely.
Yeah.
Yes, to bend the feedback arrow, and you bend back to learning as a category that you have been describing, rather than causal. It's learning, which is always...
Yeah, I mean, I'm addressing the causal question because it's so fundamental to metaphysics, I suppose, and to my mind, it is got a lot of problems in terms of how it's perceived from the biosemiotic perspective. I think biosemiotics has to address that, and that's what I've been doing. So I've basically been critiquing the idea of causality and in this context. So yeah, that's in part, that's a good deal of my paper. I would say 1/3 of the paper does critique that side of things and presents an alternative view that I think resonates better with biosemiotics.
And
Here
co-construction.
we have to do the breakout room now. We've got 12 minutes before the next session. Okay, please, everyone, go in the breakout room. Peter, pick up your comment right where we left off. Okay, but on the other side. And Lamilla, please start the clock for 12 minutes. Okay, the room's open now. And if anyone needs to get in, just let me know. Peter, I'll put you in right first. Mark, did you not join the breakout room?
I don't know how to.
Oh, just hit join.
Where's join?
I'll put you in.
Sorry.
Hit the breakout room button. Is okay?
Oh, thank you.
No worries. Hi, Yammer. Ready to chair the next session? You're muted, Yammer.
Yeah.
Okay. Perhaps, Yammer, may I ask you to begin by once again, and I'm guilty myself, but not as guilty, ask people not to comment during the talks because people are, presenters find it distracting.
Yeah. Chat, right. I will warn not to.
Yeah, if in between the talks, even during Q&A, I guess is a little better, and in between, but not actually during would be good, if possible.
I will ask them to chat if they have to
Privately.
In private.
Yes, exactly. Very good. I'm beginning to feel my energy fading today.
Well,
once the terror and the fear wears off, then there's nothing left. First 2 days were just terror. Then now it's wearing off. What is Philip up to? Philip, what are you doing?
He's going to jump into the river, I suppose.
Oh, I guess so. All right. Well, a little beefcake for the ladies, I guess.
Well, I don't know how it's in Singapore. Here it's rather hot and humid. It must be worse where you are. I just came here to university to enjoy the air conditioner and also be a bit safer against electric shortages, just in case.
It's a good backdrop where you are, Yammer, there. And yeah, well, here it's steady every day. We're the equator, so it's 30, 30, 30, 30, day and night, every day, no seasons. But yeah, Claudio's in Spain now. He says it's not too bad. Yeah, it's about 32. It goes up to 40 and above there this time of year.
But it also depends very strongly on humidity. Humidity makes the whole thing unbearable, really.
Yeah, agreed. Okay, let me just I'm going to actually send the board a quick message now, and I'll be right back.
Right. Hi, Oscar. I'm about to introduce you. Would you like me to warn you softly when you have 5 minutes to 20?
Yes, that would be very nice from your part. Yes. Maybe raise your hand virtually, because I think that makes it easier for me to see your box on top when someone raises their hand.
Okay.
Otherwise, you can just say it verbally, no problem.
Yeah. I mean, if you overcross the threshold too much or approaching the 20 minutes limit, which you can of course exceed actually theoretically. I mean, 10 minutes Q&A is not a strict necessity. I will keep on warning you.
Thanks. Anyway, I have my timer ready, so I know when you will be close to calling me.
That's our kind of presenter. All right, I'm going to tell the breakout room they have 30 seconds.
Are you just telling them or are you closing the breakout?
Well, when you close, they get a message saying there's, I guess, 50 seconds. Is Joanna there? Ludmila, is Joanna there with you? Let me just see. Okay. Let's wait for everyone to get back.
Don, do you mean Johanna at NAV?
Yes, is she there?
Yeah,
Not yet?
she is. I mean another. I can call her. She's sitting there in the sofa.
Yeah, would you please?
Oh, I suppose we have to start.
Yeah.
Okay,
Yeah, thank you, Yammer. I need to just make a quick announcement. You can pass this on to Joanna. Just this moment, we had a cancellation for our 6 o'clock talk today, Nicole Rosamond. So Joanna and Boris will go on right after Michael Jacob, okay? I'll remind them again during the break. Okay? Thank you all for your and cooperation. Yammer.
Oh. Welcome back, everybody. I'm glad to introduce Oscar Miyamoto. Please, the floor is yours.
You are muted, Yakmur.
Yes, I have muted myself.
Oh, sorry. Then I lost the cue for entering. So I'll start sharing my screen.
Please.
How does it look? Anyone seeing anything moving there? Yes, okay. Perfect. So thank you. I will start now. My timer. So thank you for being here, everyone. This is very exciting for me. This is my second participation in the gatherings. And last year, maybe some of you remember, I presented something on episodic memory as well. And basically, this time what I'm going to present is going somehow into the particulars of a species or a family of animals. And basically, my goal is to somehow attract or catch your eye into this field that is episodic memory in some animals. And on the other hand, share with you what is my goal or where I'm directing with this intention that I have of having a biosemiotic perspective of episodic memory in non-human animals. Okay, so far so good. But first of all, I just wanted to mention that I've been listening some keywords that have appeared in the gathering so far. And as a way to make this connection with those words, I just wanted to say that maybe this talk would be interesting for those of you who are into this non-linearity that Yakmur presented yesterday, or what Kalevi called semiotic memory, or what Tyler mentioned as teleodynamics being driven by thirdness, or what Professor Deacon mentioned as the interpreter that goes beyond the interpretant, what James mentioned, if I remember correctly, as self-communication. And if Professor Jesper Hofmeier was here, well, maybe he would also speak about semiotic causality. And more recently, I overheard Morten saying, speaking about this first person animal phenomenology that is totally related to my topic. So I'm very happy that Morten was before me. So it makes things to connect. Okay, so episodic memory is a cross-species modeling system that has been found to exist in many different species. We have currently evidence, like sufficiently studied evidence in particularly rodents, great apes, and corvids. I mean, birds in general, but corvids would be more particular. And of course, in humans. So as I said, my goal today is to go into the particulars of corvid episodic memory. And in this case, you will be seeing, yes, this species, the Californian scrub jay. Okay, and as a reminder of what episodic memory is for us as semioticians, I will be sharing with you this definition that I've put together in a way, applying some Persian terminology. So basically, episodic memory is an interpretant, that is a mediator, causing multisensorial images or representaments for us to stand for something absent, in this case, spatiotemporal scenarios, either past or future. And this would be the object in some capacities or intentions in as much ground to an agent or an interpreter, if you will. So this would be like the core basic definition that I have worked with in a more general sense. But now I will try to go into the particulars of this Corbett paradigm. Okay, so this Corbett paradigm, basically the research shows that the Californian scrub jay is able to behaviorally answer 3 questions. The first one is, where were you and what were you doing X time ago? Of course, these questions are not asked verbally, but are in a way presented to these episodic agents through different experimental situations. And I will be going into the particulars maybe later. Second question that they're able to answer behaviorally. When were you last at Y and what did you do there? And thirdly, when and where did you do last see? So as you can see, these are somehow interconnected, similar ways of responding the same. But basically, these are how we can test episodic memory in non-human interpreters. And I will direct you to this paper in case you want to know more about these questions. Okay, so what is the utility of this pragmatic way of approaching episodic memory through behavior? Well, it's something that is called representational binding, at least from their studies in episodic memory. That's how they call them. And it's basically that the utility of this what, when, where criterion is that the simultaneous retrieval and integration of information about these 3 features of a unique experience can be indeed demonstrated behaviorally in animals. And just for the record, this has been also applied or extended to, as I mentioned, the great apes and rodents. So yes, this is a cross-species model of memory, so to speak. The what, when, where criterion. So far so good, right? You're still listening to me? Because I'm not seeing you. Can anyone give me some?
Yes. You're coming through fine, Oscar. Okay, you're absolutely coming through perfectly.
Good, okay, just checking. Very well. Then just some visual imagery here. I wanted to share with you how this type of experiments look like in a very cartoonish way. Is that, well, on the one hand, these experiments, what they do is that they replicate these naturally occurring environmental and social demands faced by the Californian scrub jay in nature or in their habitats, and they play around with that in the lab. And they even used hand-raised scrub jays in order to have these different control groups to prove that episodic memory is not only like ontogenetically or phylogenetically developed in a way, but it's also an intrinsic capacity or a mnemonic capacity of these living beings. Anyhow, and basically the core experimental argument here, or observation, sorry, is that the birds are able to, yes, retrieve, to hide food items that decay at different time rates. Like waxworms decay faster than, for instance, crickets, and crickets decay faster than nuts and peanuts and so on. And experiments play around with this temporal decay, so to speak, of the food in such a way that they test how these birds are able to remember this decay rate through certain phenomenological modeling systems, so to speak. Okay, and the paper that I suggest checking is this paradigmatic paper by Dickinson and Clayton. And basically what they show is that this episodic behavior cannot be explained only via, for instance, circadian rhythms, environmental hints, relative familiarity, classical conditioning, and so on and so forth. Of course, these, so to speak, mnemonic mechanisms play a role in episodic memory, but these have been ruled out as the main neurocognitive mechanism for these birds to be able to remember where, when, and what they hit in such a way that they can retrieve it later before it's too late and the food is unpalatable. Okay, so in summary, what this experimental paradigm, what I'm trying to just catch your eye with is that they have three behavioral fallible criteria. Number one is structure. And as I said, basically they found that the corvids form this sort of integrated memory or representation of the what, when, where. Then they act on the basis of this memory that is tied to this unique episode. And the most interesting criteria is that these birds are, of course, able to update, to flexibly perform this retrieval of information in the sense that the more they are able to think about past experiences, well, the more they are able to, of course, anticipate new ones. And this is named temporal generalizations in these studies. Okay, this is just another reference for the paper. And okay, for us as semioticians or biosemioticians, well, we call structure is no other than these representaments that we always speak about. These representamen-mediated experiences, or this multisensorial qualia that is constantly mediating experience. And the evidence suggests in these studies that sensory memory, that is another mnemotic subsystem in relation to episodic memory, is the main responsible, allowing this qualitative recognition and discrimination between similar catching episodes. Because in experiments, they play around with trying to confuse the birds and tricking them into believing that they remember something. But anyhow, they're able to recognize and differentiate similar episodes. So they have this, that's why this is called episodic memory, because it's a memory for uniquely lived episodes. Okay. So in this case, the what would be, yes, all the sensorial array of experiences that these birds are capable of. That ranges from colors to proprioceptive feelings you can see in the screen. The where aspect would be the most basic elements of this spatial type of locations, positions, configurations, and so on. And the when, this is a very interesting part. Of course, they are sensitive to relations of precedence, simultaneity, and succession. In other words, they are able to actually feel what comes first, what comes second, and what comes as a simultaneity of actions. Okay, then the content criteria. So basically what I use to describe the content criteria is the notion of object, but not object in abstract. As we have been saying in communication, there are no objects as such. But in this case, I would argue that there are object-oriented actions, or this controlled behavior displayed by these Californian scrub jays. And in this sense, evidence shows that procedural memory is the main memory system in relation to episodic memory, responsible for, yes, the enactment of this quantitative effort, this bodily behavior in relation to this representational binding. For example, yes, they're able to act on the what, so they can inspect the what caches are more perishable than others. They can act on the where. They can physically locate these hidden caches in different areas. And of course, they can act on the basis of when, so they can anticipate when a cache will no longer be edible. So for instance, what they do is that they eat fresh ones first, nuts later, and they stop minding these expired catching sites, so to speak, or these pillaged caches, because of course, conspecifics also steal these food caches. Okay, and thirdly, yes, as you were expecting, the flexibility aspect would be the interpretant realm of things in semiotics, right? But not only interpretant-based intentionality, but what has been described by Professor Donna West, and I wish Professor West was here with us, is something that she calls virtual habits, or that she has studied from Peirce, that is called virtual habits. And just for the record, this is basically the pre-enactment of episodes in this some sort of like phenomenological space where iconicity and indexicality work together in order to propose arguments. And well, this is also on the basis of Professor Frederick Stellenfeld's natural propositions, but that's a different topic. Okay, so in this case, it is episodic memory in relation to semantic memory, the one that allows updating these temporal generalizations in this explicit episode building. Okay, so in this sense, the what would be these food caches, different cues, rewards, environmental items, everything that is relevant for the scriptures to remember when it comes to this feeding behavior. The where, as I mentioned, this would be more developed mental maps or these spatial models of a given environment, like a natural habitat or also a lab setting. And the when would be this cognitive mental replay of a relieved or pre-lived experience. As I mentioned, with this sensitivity to the precedence, simultaneity, or succession with respect to similar episodes. And when I write cognitive mental replay, basically I'm referring to the fact that episodic memory is a declarative type of memory, where the subject or the interpreter, in this case, knows that they know. And yeah, this is a feature that has been once experimentally demonstrated in other species as well. Okay, so this is leading me to what I'm really wanting to achieve here as part of my research in the PhD in Tartu University in the semiotics department. What I'm really trying to do, in other words, is to provide a model of memory. In this case, the model would be some sort of like a cross-species model of memory. If you will, this would be like a functional cycle of memory model that could not only apply to corvids, but could also apply to account for the experimental evidence on rodents and great apes. Okay, so the model more or less looks like this. It's a work in progress, and I would appreciate if you saw it as that. So, okay, as I mentioned, the realm of firstness would be this simultaneity that is constantly mediating experience. This is what they, in this study, is called structure, but what we call representaments. And this is a simultaneity. This is what Professor Kalevik would mention as the phenomenal present, so to speak. Then, oh, can I change slide? Yes, then we would have these spiritual habits that are constantly working closely with these sensorial experiences. And the way this connect is through something that I won't be having the time to define right now, that is called the core network's pattern reinstatement. And this would be thirdness. I mean, the virtual habits would be a thirdness because they precede what we call control behavior in ethological terms. Without the existence of virtual habits and this interpretant-based intentionality afforded by these memory systems, we would not have this episodic consequent behavior. And the way in which this behavior is expressed by the means of sensory memory is through the somatic nervous system. And I won't be going into the particulars of that because I'm still learning and I'm still researching on that on the basis of these experimental studies, right? And okay. Finally, the official explanation of the model, because the model can be tricky, geometrically speaking. So we'll be just reading this. If you follow along, that would be great. So this diagram represents this semiotic causality of episodic memory. And the blue sphere, oh, there's a message saying that my internet connection is unstable. I hope everyone is listening to me all right. Okay, so the blue sphere corresponds to this telodynamic precedence of intentionality, this metaphysical realm. And then the purple sphere would correspond to this phenomenological simultaneity of sensations. And finally, the red sphere to this neurophysiological succession of actions. And this phenomenological causality, in turn, reflects the logical hierarchy between interpretants, representaments, and objects, which, by the way, is not only linear, but bidirectional. Okay. I have a couple of minutes left, I think, so I will be just making a further translation of my model In purely percent terms, the model would be basically saying this, that episodic memory is made of an interpreter, an experiencer, and an actor in constant biotranslation. And I won't be going into the particulars of the model. I just wanted to show this as some sort of like a further explaining myself. And by the way, this could be seen as belonging to the so-called A-series timecode in biosemiotics. So I suggest you to read this paper by Nomura et al., which basically explains all these temporal phenomenologies that we have been discussing in previous presentations. I will leave it here because I know that my time is up. And thank you so much for your time and your attention. And we're looking forward to your feedback. Thank you.
Thanks, Oscar. Do I see any hands? Virtual or natural, Tyler?
So Oscar, excellent presentation. I liked what you did with the diagram. Considerable improvements since the last presentation a few weeks ago. And I saw that you removed the Charles Morris vocabulary as well as the Aristotelian elements, and it's really pared down now. Maybe a little change with the color. It looks really nice now.
Thanks.
Have you given any more thought to the sequentiality of the diagram?
Absolutely. So just for the record, what I'm trying to geometrically represent with this model is that there is a sequentiality, a hierarchical sequentiality, but also a bidirectional causality, so to speak. And if I may, just for the sake of being precise here, I will just show the model again. So yeah, basically what I'm saying here is that this time arrow, so to speak, goes both ways. Once that you decide what to do, and once that you do, you can have this feedback and change your mind. Is basically what I'm trying to express with this model. So yeah, I still need to improve this representation of time there.
Okay, Ludmila.
Thank you, Oscar. Great presentation. I agree with Tyler's observation on that. Your progress is really great. It's been 1 week or so. And I wanted to ask you to comment more on your diagram again on those circles, like you have blue, violet, and red, and blue referring to precedence, red, etc. So I didn't really get why do you associate the precedence with teleodynamics, and on the other hand, the red circle oriented towards the future with the causality, because I would do the exact contrary. So if you can just explain this shortly, thank you.
And I mean, the selection of colors is completely. But what I'm trying to say here is that the precedence, so take into account that this is an anticipatory phenomenology of time. So as you know, the future becomes present and present becomes past. In this sense, the logical influx of time is anticipatory. So future becomes present and present becomes past. And in this sense, yeah, it's compatible with the versus temporal expressions of stage that are called precedence, simultaneity, and succession. So it's a completely Peircean phenomenology of time here.
Peter?
Hi. You know, there are these tape recorder models of memory in which all the internal neural events that lead up to a particular event, and then the aftermath of that in terms of hedonic rewards and things like that are recorded in sequence. And there's a whole psychology of temporal associations whereby a timeline of events and rewards is assembled from their occurrence. And so, you know, one thinks of episodic memory as just a very basic kind of memory that can then inform, if you run the tape faster than real time, you can anticipate whether you're going to get rewarded or punished on the basis of what you did last time or times before. So I think it's integral to nervous systems. We radically underestimate what animals can do.
Right. So my thoughts on that would be basically that one of the philosophical standpoints to understand episodic memory is that retrospection is not rewinding, because we do not reconstruct temporal causality as if it was thermodynamically going backwards. We do not see, in order to remember yesterday, we don't have to rewind the tape backwards. So rather than being like a motor, like a hourglass, memory is more like a mirror, in the sense that every time that we need to remember something, we arbitrarily jump in time, so to speak, and then we replay forwards. So these temporal phenomenologies have forwards motion in a way.
But if it is like a tape recorder, you can play the tape faster than real time, which hippocampal replay seems to be doing, then you have already an anticipatory mechanism. If you access the memory, play it back, you can then predict what the future will bring on the basis of past experience.
Yeah, it makes a lot of sense. I mean, there are different interpretations of episodic memory. There is the strong continuism, metaphysical discontinuism, and a bunch of others. I am on the side of strong continuism. We can have a deeper conversation on that, because right now I'm thinking about your point. Mm-hmm.
Okay, if you don't mind, let's take the last question from Gary.
I'm wondering whether you've thought about the question of embodiment I mean, presumably this is implicit memory and implicit memory function. To what extent, is the where is the memory encoded, right? Is it embodied, or is it somehow out there and being received back by the nervous system?
Great question. Thanks for the question, Gary. So I will just go to my model again, take one more minute. Yes, this is compatible with the notion of embodied semiosis, because of course, final causes cannot operate in the world without material and efficient causes. And if you can see the pointer, something in the screen, I'm pointing at the cord network's pattern restatement. This would be one side of the coin of this embodied process, of this embodied neurocognitive process. And there's also the somatic nervous system, but this is only the material cause that is in a way embodying the final cause. This is some sort of teleological dimension of things with the efficient cause, that would be these actions. But there is a bunch of improvement or exploration that can be done in terms of the embodiment of memory here, because there is something called the core network. Without the core network that we share with another species, that is mainly a hippocampal structure, we wouldn't be able to actually have this pattern restatement. So in that sense, that would be the where of memory, but doesn't end there.
Okay, so we have really perfect timing as far as I can see. Thank you, everybody. Thank you. So I can already introduce Nelly Markivi, our next speaker. Please.
Good afternoon. On my point, can you hear me well?
Yeah.
Yes, excellent. First of all, I want to thank everybody for being here. And of course, a huge shout out to the organizers for being able to bring us together in the same room. So my topic concentrates on animal behavior and the alterations that take place when the environment changes drastically. I'll be employing the concept of Umwelt developed by Jakob von Uexküll to show how the behavior of the European mink changes when they are reintroduced from ex situ to in situ Hiiumaa in Estonia, so their natural habitat. And I will try to show how information gathered from local people with no science background can provide valuable knowledge on the behavior of these animals. So in order to set the scene in this limited time frame, it suffices to say that we interviewed 95 people who live in Hiiumaa, locals. And although the main aim was to pinpoint how the locals have adjusted since the mink has been reintroduced since the year 2000, there were several interviewees who gave us valuable knowledge about the behavior of the mink. And these interviews will provide support for our Umwelt analysis. And it also suffices to say that the captive conditions of the mink, let me see if I can change the slide, yes. The captive conditions and in situ conditions are highly different for this endangered animal. So the minks are solitary, small, slender, and semi-aquatic animals. They inhabit the banks of rivers and streams. You can see Hiiumaa, I don't know if you can see my mouse, but it's the upper left island of Estonia. Their diet consists mainly of fish, amphibians, crustaceans, but also small mammals, some birds and some insects. Since they are mostly active during the night, it is relatively safe to presume that they tend to have very little contact with people. So their hidden lifestyle is further supported by the fact that the mink is sensitive to anthropogenic disturbances, for example, noise. And the above information about the life of in situ European mink becomes relevant in comparison to minks living ex situ. So in the enclosures of the minks who are being prepared or were prepared for reintroduction in Tallinn Zoological Gardens, those enclosures were about 20 to 50 square meters. They have natural vegetation, ponds are added to the enclosures, and the minks are fed once a day with defrosted rodents, fish, chickens, or minced meat, with occasional live prey as well. The contact with people is kept to a minimum, only for necessary husbandry, but if necessary, then the minks are also trained to swim, for example. And the feeding activities or husbandry activities take place during the day, the work hours of the keepers, so the minks are active during the day. The enclosure is also fenced off from the side and above, so terrestrial nor aerial predators can access the minks. And I can say that in the years 2000 to 2003, 77% of the minks that were reintroduced to Hiiumaa died because they didn't have any predator avoidance skills. So from this comparison of the minks who live in situ and ex situ, we can see several differences in the meaning carriers of food, for example, or their living conditions. So this case study enables us to scrutinize what kind of new objects can be reintroduced or introduced to their basic functional cycles. And I think it's also worth mentioning that Yksküll, in his analysis, did not consider what happens in the Umwelten of allo animals when there are changes in their environment. However, our case study clearly indicates the decoupling of the environment and the allo animal, which is accompanied by major changes in the Umwelten of the minks. Thus, we need kind of a more contemporary, but still Yksküllian solution to tackle the issue. And Morten, who also gave his presentation earlier today, has directed his attention to exactly this aspect and created the notion of Umwelt transition, which he defined as lasting systematic change within the life cycle of a being, considered from an ontogenetic, phylogenetic, or cultural perspective from the typical appearance of its Umwelt to another. So what we discovered with our case study is a special case of Umwelt transition, which we call Umwelt reversion. We define Umwelt reversion as a process where an animal or a population of animals return to a previous state or configuration of Umwelt after going through a considerable alteration in the Umwelt, regarding mainly the four functional circles then. And we would describe Umwelt reversion as a situation where animals or populations Umwelt has been altered due to external factors, for example, captive conditions, habituation, or other anthropogenic factors that have caused considerable changes in the Umwelt of an animal or population. But upon returning to the external factors to their previous state, the state of umwelt of an animal or a population reverses in a way that pre-existing meaning carriers and meanings are reacquired. And now I would like to give two examples of two different functional circles. First would be the food. So in the brief description of in situ and ex situ diets of the European minks, we can see tremendous differences. There is very little live prey fish or crayfish in captivity, and there is no minced meat or vitamin supplements after the release, which makes us question about the strength between the object of food and the meaning carrier. When the minks are being reintroduced, the animals have a transition period where, although they are still fed with defrosted rodents and minced meat, they can also catch occasional insects, amphibians, or even fish that happen to go through their enclosures that have mesh-wired fences. And one of the interviewees who had the mink enclosure on his land concurred that the stream flowing through the enclosure has pikes, river burbots, and eels in it, which some of them are the preferred fish of the mink. And the same interview also confessed that his son, who fishes, took much of his catch to the minks. If here we can see the tendency to offer minks more natural food, then there is also a clear counterexample where a mink family, after leaving this transition enclosure, settled in a harbor seawall next to a pizza restaurant. And the owner told us several different stories about his summer. And I quote, "The mink wanted to drag away the flour bag, but since her teeth are sharp, they penetrated the bag and the whole kitchen was covered in flour." The mink also dragged some pizza crusts under the hood of the car and stole food from customers. This certain inclination towards anthropogenic food sources is also echoed by other interviewees. For example, one of them recalls that the mink climbing onto the table in their home yard during his child's birthday. And another one remembers feeding the mink with grilled chicken. And perhaps the most peculiar instance is the mink that drank vodka. So the interviewee told us, and I quote, "Since the mink liked to play with the vodka bottle, the builders played a trick on her by pouring a bit of it on the ground. She tasted it and ran to the steam room to drink some water." So, and there were also several recorded cases of minks raiding hen houses, which is also an unusual food source for the mink. But these examples kind of help us to illustrate that there is a very wide range of objects that possess the meaning carrier of food for the reintroduced European minks. It seems that they freely incorporate new objects to this functional circle. However, what is interesting here is that the described instances mainly occurred with the minks that were born at the breeding facility and brought to the island, but not with their offspring who were born in Hiiumaa. In fact, their offspring were too cautious of humans to take advantage of anthropogenic resources. The claim that captive-born minks use unusual food sources upon reintroduction, but cease to do so after some period of time, is also supported by relevant literature, so not only by our interviews. So this is the figure which kind of represents this umwelt reversion. We can see that the typical objects of food for wild mink populations are represented by in situ diet. When the animals were caught and transported to the captive environment, a major umwelt transition in the lives of the animals took place. The diet was also completely replaced with a new one, which indicates that the meaning carrier of food denoted totally different kind of objects. But since the minks survived and thrived, we can assume that the connection between the meaning carrier and the object is not strong. When the minks are reintroduced, another major umwelt transition takes place. They are kept on the on-site enclosures, and new meaning carriers are added to their umwelten, especially for these specific subjects. And after leaving the enclosure, they are free to introduce additional objects of food. And thus, during this transition period, the diversity of objects in the functional circle of the food is the largest. What is interesting is that after this initial transition or transitional period, when the minks have gotten accustomed to in situ life, we can see that they exclude certain objects as food, like anthropogenic food resources. and relationship between the meaning carrier and an object in the given functional circle becomes similar, if not even identical, to the one pre-existing in situ conditions. In this case, we can say that this Umwelt reversion is evident, and as pertaining to the meaning carrier and the objects in the functional circle of food, we can see that after the transitional period the minks reacquire this suitable configuration in their Umwelten that enables them to manage in their native habitat. And I think it's also important to stress the active part that the mink has in this Umwelt reversion. Though the anthropogenic resources are still attainable after the reintroduction, they interpret the environment and opt for other food resources more compatible with their native habitat. And if I have time, I will give the other example, which is human and mink communication, and human representing in this sense an enemy, not the whole group of enemy meaning carrier, but just one. So this is a bit different from the Umwelt reversion that takes place with food, because here the object stays the same, but the meaning changes. So in food, we have different objects added or taken out of the meaning carrier, or the meaning carrier denotes different kind of objects, but here the object stays the same, but the meaning attributed to the object changes. So we briefly brought out in the beginning that in situ minks are wary of humans and human disturbances, and thus they tend to kind of stay away from human habitats. But many examples, again, brought out in relation to changes to functional circle of this enemy proves otherwise. So, for example, one of the interviewees who took care of the minks, the same one who talked about feeding fish to them, and I quote, said, "They heard us approaching from afar. The mother was waiting next to the fence till we started throwing the mice over it." Another interviewee stated that humans were definitely not strangers to her, otherwise she wouldn't steal flounders from a bucket that was only 1 meter from me. And a third one said, "She was too used to humans. When we had guests during the summer, then she climbed onto the table. She was used to people feeding her." And this insight of the interviewee into tying the affinity towards humans with food is important, because it has a clear connection to captive rearing of these specific minks, and thus it is normal for them to associate humans with food. So in turn, humans themselves kind of gain a positive meaning. There are also some indications that only the females who were brought from the zoo possessed this positive association, whereas their offsprings who were born on the island did not. For example, one interviewee told us, "Only the mother came in the house, the cubs stayed away. When I wanted to approach them, they would hide. The mother was different from the cubs." And another interviewee told us, "After they left the enclosure, we never saw them again." Thus, we can say that the offspring who have much less contact with humans are cautious of people and show hiding and escape reactions. And another interview told us, "There are very few streams on the banks of which I don't see the footprints of the mink, but now they are no longer human companions." And the last quote indicates that although there are many minks on the island, right now they have a self-sustaining population, they stay hidden from humans. And in the past few years, there are actually no recorded instances where a mink has made its way to human settlements. So again, I would maybe like to reiterate that in the case of food, it is the objects that changed under the meaning carrier. And with humans, we would like to say that the object itself does not change. Thank you. But the meaning attributed to this object, so which functional circle the object belongs to in the Umwelt of the European mink transforms. The change takes place with the meaning change, I think is appropriate Umwelt transition for a life in a natural habitat. And similarly to the Umwelt reversion regarding the functional circle of food, with Umwelt reversion regarding the meaning of human, we can see that the agency of the mink has a central role to play. So in the captive environment, the relationship between humans and minks is inevitable, but in situ, the activity of the mink determines the contacts between humans and the minks themselves. And I have a couple of quick conclusions. So I think that already tackling like 2 functional circles out of the 4 main ones through the analysis of Umwelt by employing this concept of functional circle, meaning carrier, and Umwelt transition, it is possible to explicate the changes that take place in animals' lives. And thanks to their agency, when there are major changes in their environment, they are either able to cope with the changes or not. We revealed that in the case of European mink, the functional circle of food and enemy as related to human undergoes a transformation that can be described as Umwelt reversion. This means that this functional circle that has been heavily altered in captivity obtains characteristics common to functional circles of in situ population due to mink's own activities. And we mainly base this explanation on observing the reintroduction of animals who require the sign relations to the environment and other living beings that are similar to their wild conspecifics as compared to their ex situ counterparts. And though we only touched upon 2 of the 4 basic functional circles, I think that similar investigation is also possible with the functional circle of medium and partner. And I would definitely suggest looking into that. But thank you, that is all on my part.
Thanks a lot for keeping. We have even more time than expected. I see the hands, please. Virtual or otherwise.
Tyler and Oscar had questions, I think.
Yogi does. I mean, I'm trying to follow the virtual hands, but if Oscar raised his hand before.
I was clapping virtually. You confused it with the raised hand.
Okay, so Yogi then.
So thanks, Nelly, for your presentation. I'm wondering how far we can sort of generalize these sort of these examples of reversion, right? And if there are sort of tipping points that have been identified where reversion doesn't work or where it sort of hiccups in various ways, and whether you think this is sort of a generalized question, right? You know, we could even go as far as saying, you know, some people think there's a, you know, a default human diet, right? And if we cleared away all of the industrial epidemics and advertising, that we would default to, say, maybe our regional or bioregional diets. You know, we also see, like in other organisms up and down, you know, for example, with plants, that when they're given fertilizers, that they uptake lots of macronutrients, but they then stop uptaking micronutrients. And thus our food will have less micronutrients. So there seems to be at least a prima facie argument that, you know, for plasticity, right? And then there's this question of reversion. And I'm wondering what is necessary in the habitats that these mink are reverting to. That's, you know, because assuming that these are intact habitats, right? That they're being re-released into, or, you know, if they were held, say, for 20 generations, you know, if that would impact this sort of reversion.
Definitely. I mean, there are a lot of species. Let's take the European bison or the Pierre David's deer. For Pierre David's deer, they weren't in the natural habitat for over a millennia and a half. So there is no comparison to make what is their natural habitat or their natural food or anything like that. With minks, it is easier because they there are a lot of mink, not a lot of mink, they are most endangered small predators in Europe, but there are still enough mink in the wild left. And I think this specific case, I don't think it makes any kind of generalizations or claims about all the animals or all the species or the reintroduction programs. But minks in Estonia, the last ones were caught, I think, at the end of 70s or at the beginning of 80s. So the transition period from in situ to the zoo environment to back is not that long of a time period. So we wouldn't have this kind of comparison material to make. If that answers your question.
Yeah, thank you.
Philip?
Hi, Nelly. Excellent.
Hi, Philip. You have got a shirt on now.
I would like to ask you, so based on your findings, I guess introductory program is still going on with the European mink. So what would you suggest for changes in food diet or these procedures around in the zoo to make this Umwelt reversion in food cycle more easy for the mink?
Well, I can suggest whatever I want, but the fact is that the zoos have their own kind of conditions and monetary restrictions and so on. But what I think that the main aim of this research was actually not to find out how the minks themselves have coped, but how the humans have coped. And this is something that we picked up along the way. But from this research, I could basically even say that they don't have to change anything because this reversion takes place so quickly. Only the females that are born in the zoo have this kind of affinity towards humans and their food, but already the generation, they take to the island females who are pregnant. So they give birth to them on the island. So basically, the dispersal period is from, I don't know, late April till September. And already those cubs who are born on the island, they already do not take advantage of human resources anymore. So it takes so little time that I don't think it is even necessary to change anything in the captive conditions.
But on the other hand, you said that 70% of minks died because of their...
That was during 2000 and 2003. And they used what was called a hard release method then, which means that the animals were taken from the zoo, put on the riverbanks and said like, bye-bye, go and find your own food and stuff. But when they started using the soft release method, meaning that they brought the pregnant females and they had this transitional enclosures there and they were free to come and go as they pleased. After that, they have a self-sustaining population. So no new minks have been taken to the islands since 2017. And they are thinking about expanding to process to the other island, Saaremaa.
Excellent. So it will be one of, I don't know, only 10, 10 programs of this kind that would be successful probably.
Mm-hmm.
So if you don't mind, let me give myself a word for a question. So can we assume that it's actually what the cops are learning just by imitating the behavior of the mother, where, well, in this case, when they are released, the pregnant mothers in the island, they don't have, of course, the opportunity to behave otherwise because of the new conditions. So the cubs are born into that situation where they see their mother doing whatever is possible and they immediately learn it. Can we assume that it is this mechanism that's responsible for this very fast conversion?
If they would imitate their mother, then in that case, they would have more affinity towards humans. Mm. So I think that the fear of humans is stronger in them than it is with their mothers. But well, it's only a speculation.
Okay, if there are no further questions, should we wait 5 minutes or should we immediately pass to the next one, the last one?
Why don't we immediately go to the last presentation and we can have 5 minutes longer on the breakout room.
Okay. Thank you very much, all.
Thank you, Nelly. That's great.
Thanks a lot. Since the next presenters are already there, we can immediately start the next one and the last one of this session with Jana Schwarzova and Ludmila Laskova. Please, the floor is yours.
Thank you very much. Can you see my screen? Okay. So, good afternoon to everyone. Today, with my colleague Jana, we would like to present Charles Peirce, not as much as a semiotician, but rather as an evolutionary theorist. Well, because Peirce's science doctrine has been already widely applied to the field of biosemiotics, but his evolutionary essays also deserve major attention. So what we plan to do is to compare Lamarck's and Peirce's views on evolution, and basing our conclusions on proper mentions of Lamarck by Peirce. And as you know, Peirce widely commented on evolution in many of his writings, mostly published in between 1891 and 1893. Those papers are famous as monist papers, but were also published posthumously with this famous book entitled Chance, Love, and Logic, and edited by Maurice Cohen. So this will be a sort of short excursion to the history of ideas on evolution, but we would also like to connect our findings with the contemporary research in biology, concretely to the current findings in epigenetics. And I think that Jana is the best candidate for this task because you probably read her recently published book on epigenetics. So if not, I highly recommend reading that book. We will show you in the last slide this publication. So to introduce the evolutionary theory by Peirce, it has to be said that his evolutionary theory meets his philosophical and mathematical understanding of the universe in a vast sense of relations between mind and matter, potentiality and actuality, or individuality and continuity. Chance, law, and habit are three basic components of Peirce's doctrine, and they are defined by mutual reciprocity. When applied to evolution or evolutionary theory, they acquire a new form and a new nomenclature, becoming accordingly Tikasm, Anankasm, and Agapasm. Tikasm was already mentioned a couple times yesterday, for example, by Tori. So we will not concentrate that much on this first type of evolution, but we will concentrate rather on the second and third types of evolution, because this is how Peirce calls the three components of his doctrine when applied to evolution, and he uses the terms of Tikastic, Anankastic, and Agapastic evolution. So while he attributes the evolution by chance to Darwin, he attributes the evolution by law to Lamarck. And the third type of evolution, the evolution by habit, is Peirce's own evolutionary theory. Thus, Lamarckian is the evolution as understood by the philosophy of necessitarianism. You can see that Peirce's reading of Lamarck stands in contradiction to the traditional reading of Lamarckian evolution as vitalist or goal-oriented. Mechanical necessity is the term more effectively explaining what Peirce expresses by the principle of Anankasm. Law here is to be comprehended in terms of physical laws, so that any step in evolution would be explained by a physical, chemical, or environmental necessity. The necessity is in its part driven by causal process. Causality is contrary to randomness from the first type of evolution, develops into the central mechanism behind the second type of evolution. Causality is an ankastic evolution, is development by the mere force of circumstances or of logic. This is the quote from the essay Evolutionary Love. So causality is dependent exclusively on the pressure of external circumstances or cataclysm in evolution. Another quote from the same essay. Therefore, Lamarck's evolution is a sort of reduced to such an understanding of causality in the evolution of species without any scope to attain. But even more radically, we could say that anankasm as causality is in a direct contradiction with the teleological understanding of causality, or let's say a teleological understanding of evolution. And according to Lamarck himself, as Tiana will confirm, evolution is not to be understood in a teleological manner. Rather, there is a direct causality going in a direction cause-effect, where cause is the experience of parent and effect is, for instance, a prolongation of the neck of the offspring. And thus, the only motivation of evolution is the mere force of circumstances, is blind play of logical necessity. So Lamarck has a mechanistic explanation of evolution, and he does not really use the teleological one. Now we can move to Peirce and the so-called third type of evolution, or the evolution by habit or agapasm. But some authors also mention synechism instead of the term agapasm in the third type of evolution. And synechism can be also understood as evolutionary spirit or a natural tendency of cosmos towards a progressive and continuous growth directed to a given goal. This goal in the evolutionary understanding might be seen as a progressive perfection, a trying to become better than before. Therefore, Peirce's evolutionary theory is sometimes referred to as teleological, in reference both to synechism and agapasm. If I can mention some authors who talk about the teleology in Peirce, for instance, Burks or Breer. And in this understanding, teleological principle would be the third completing principle, thus completing chance and law with teleology. Well, we know that teleology is a very controversial, even repellent term in the scientific environment, although in biology, somehow difficult to completely omit. It must be clearly stated that there are several conceptions of teleology. First, teleology is related to the notion of habit, of course. Habits do not emerge gratuitously, they are directed to definite ends. Namely the search of nurture, for example, or a removal of the source of irritation. And in this manner, Peirce explains, for example, the habits of our nerve cells as the primary source of reflexes. So he explained reflexes as habits of nerve cells to remove sources of irritations. Thus, the reflexes become automatized, but initially they were habits acquired by nerve cells. Now, Jana's turn.
Hi everyone, greetings from Bohemian Forest. I will start now with Aristotle, because that is where probably teleology started. And, for Aristotle, every living being has a purpose of life. It has a goal to remain alive and to realize its form through ontogenesis. Ontogenesis was, like, for Aristotle, the goal-oriented process par excellence. So every organismal activity, its organs, its manifestations, everything is adjusted to this one goal, to the way of life of the organism. Yet, to see teleology in ontogeny, and is not supposed to be understood as ontogeny having some sort of subjective motivations or intentions. This goal-oriented emergence of form, ontogeny, is naturally existing. It does not include intentionality. You can take the example of, for example, regular walks usually lead to good health, right? No matter the circumstances, no matter the subjective intentions, whether you want to go to the park with your dog or meet your mistress, or whether you walk in a forest or in a park. So walking is usually something that leads to health improvement, no matter the circumstances. As Denis Walsh puts it in his book on agency, purposes occurrences are robust across a range of different initial conditions and mechanisms. So, but eventually leading to the same goal. So that's what that was telos for Aristotle, without any subjective action. And I think Lamarck has had a similar conception when he introduced the concept of power of life, which is like second main concept of Lamarck in organic evolution, next to the environment influencing organisms phenotype. And this power of life, of course, these two aspects are mutually connected. And this power of life was, even during Lamarck's life or after his death, interpreted as implying some kind of finality or some vitalistic or theological force. But as Ludmila mentioned, Lamarck rejected teleology. For him, the power of life represented some kind of inherent power, physical necessity, due to which organisms' complexity cumulatively increases. He once wrote in one of his work that humans only tend to see some subjective goal or some finality in this concept. And teleology is also mentioned, of course, in contemporary biology, although, as Ludmila said, it's quite a repellent term for many. Even Monod admitted that organisms are purposive by maintaining their viability and adapting to environmental circumstances, but he introduced this term teleonomy in order to avoid teleological explanation, meaning that natural selection actually tuned the organism in such a way that organisms are purposive because natural selection and possibly other evolutionary phenomena. But there are on the other hand, there are other philosophers of biology who consider theological explanation to be completely acceptable in contemporary biology. And as, for example, Denis Walsh in his book Organisms, Agency and Evolution. And he emphasizes that this theological explanation should not be mixed with mechanical explanation. Although they are like sides of the same coin, mechanistic explanation give the answer to the questions how, however, theological explanation answer us to the question why. So I think basically whether you want to include teleology in your view, it's dependent on your own conception of evolution and concept of the organism. Whether you define evolution or organism as designed by natural selection to be seemingly purposive, or whether you consider organisms to be like goal-oriented as such, and therefore evolution is adaptive, and like in example of like organisms can plastically react to the environment, react to some affordances, make choices, be agents, etc. But back to Lamarck, what we wanted to emphasize with Ludmila here is that actually Peirce is reading Lamarck right, unlike his contemporaries or unlike his followers or neo-Lamarckians. Lamarck did not interpret the organisms as some kind of seat of will, wishes, or consciousness in a human sense, as his readers often anticipated. This near vitalistic interpretation were rather symptomatic for neo-Lamarckians in America, for example, for Samuel Butler. And there's also this modern interpretation of Lamarckism, which is also very frustrating for me, that some people think that Lamarck actually believe that there are possible changes, like intentional changes of genetic information through will or some wishes. But for example, Ronald Fisher was mocking Lamarckism in this sense in one of his books, the statistician, I mean. And Lamarck emphasized, of course, Lamarck did not know genes. He mainly emphasized the role of environment in organismal behavior. And he did not know anything about genes. He did not used to think in terms of units of inheritance. For him, the forces which were relevant were physical, mechanical, and materialistic forces. And of course, the habitual evolution, which Peirce also considers to be a major part of his evolutionary view, can be found in Lamarckian philosophy. You know, the main law of use and disuse, which means that organisms' behavior, its habits, way of relating to its environmental circumstances actually are major constituents of organisms' phenotype. Lamarck would not use this word, of course, but that's how the organism looks like, how it behaves. And when the organisms encounters new environmental conditions, some organs, some habits can disappear because the organism does not have a longer use for these. So environment creating habits is this major cause of species change. And these changes, like changes in behavior or muscle growth or organ losses, can be, of course, hereditary. But Lamarck never elaborated any deep conception of this habitual evolution. The habitual evolution was rather further developed by his followers within the concept of organic memory, which you may have heard of already from me before. It was an analogy between mental memory and inheritance, an analogy between acquisition of a trait and learning. And these neo-Lamarckians, in the whole Europe and in America, there were a lot of thinkers. It was kind of paradigm of a specific time. They used to attribute the capability of learning to all organic matter, and any experience enhanced by repetition could become habitual. Some of these interpretations were rather vitalistic, really, and some of them were quite mechanistic. But I will give the word back to Ludmila.
Back to Peirce. I will just very shortly comment on his agapistic evolution because he uses the word agape or love from the Greek word agape. And I think that this concept deserves a short commentary. Peirce takes distance from both Darwin and Lamarck, but it seems that he has more sympathy with Lamarck. And in some places, he even compares with proper concept of agapistic evolution or with the evolution by love. So the Greek word agape means love or loveliness. And surely it is difficult to understand whether the use of this term was meant is metaphorical, and if yes, in what sense, what is the metaphor? Well, Peirce sustains that the English translation of the word is not really appropriate because English lacks such a word. So I would say that he decided for this term mostly because of the lack in the terminology rather than with some metaphorical purpose. Simplified, agape is the habit to love the universe has tendency to take. But what does it really mean to say that the universe takes habits to love? For Peirce, the nature of the universe to take habits derives from the specific understanding of love as an overwhelming principle in the cosmos, where there are no contradictions to love. Hateful is only lack of love or a tendency towards love. And agapism has many forms, from physical attractions manifesting in form of physical laws, such as gravity, to various modes of affections in human culture. Agapism of physical forms, such as the gravity, might be qualified as genuine anankasm or degenerate agapism. Because of its lawfulness, this lawfulness is typical for anankasm rather than for agapism. Thus, the boundary between anankasm and agapism is not represented by a straight line. I can just show you the short quote from this essay, Evolutionary Love, where Peirce comments on Lamarck. And he says, evolution by sport and an evolution by mechanical necessity are conceptions warring against one another. Lamarckian evolution is thus evolution by the force of habit. Thus, habit plays a double part. It serves to establish the new features and also to bring them into harmony with the general morphology and function of the animals and plants to which they belong. Lamarckian evolution coincides with general description of reaction of love, to which I suppose he yielded his assent. So Peirce found the essence of habit or love in writings of Lamarck, even if Lamarck himself didn't really develop deeper in this direction. And I can mention here that also Gregory Bateson commented on Lamarck in his lecture Form, Substance, and Difference. And he also kind of found there are some features that Lamarck himself probably didn't develop, such as mind, habit, and evolution, connection between mind and habit. But for Lamarck, habit is strictly related to mechanistical explanation. And I can show you this quote from Lamarck, where he explains with the very famous example of the prolongation of the giraffe's neck, thanks to the notion of habit, how this all happens. So he uses the words such as necessity and habit, very related one to another. Now let me extend further on the relation between habit and law, or agapism and anankasm. I already mentioned this relation. So in the overall Peirce work, there is no notion which would escape the triadic explanation. Evolution is not an exception, An understanding of evolutionary habit is only possible in the triadic perspective. When I say triadic, I mean that triad is the basic relation in Peirce relational logic, and it is irreducible to dyads or monads. The essence and uniqueness of Peirce identity relation resides in its ontological threefold status. So when applied to evolutionary theory, it results in habit preceding law, or secondness as dyad precedes the triad or the habit. And the last comments by Jana.
I will make it short. I just, you know that I'm always in love with epigenetics. So I was thinking epigenetics could be a good example also of evolution by habit. And thank you, Ludmila, for your advertisement of our book. You can read multiple examples. We actually think the whole evolution is epigenetic with Anton. And I wanted to mention quite old papers that, for example, some authors like Ginsburg and Jablonka mentioned that speak about cellular learning through epigenetic meaning that some modification like DNA methylation can facilitate the reaction to external stimuli, which the cellular generation already experienced before. Also, there was also I published a hypothesis in Science about concept of instinct, which could be quite in concordance with Lamarckian view. Ludmila, please, the next slide. And meaning that behavior first must be learned, and through the repetition in subsequent generation only becomes automatic and instinctive. And there are also very nice studies lately about short non-coding RNAs, where there is actual huge transfer of these RNAs from somatic to germinal line through exosomes during the sperm maturation, which can transfer a lot of experiences of the previous generation. So Ludmila will quickly conclude.
Okay, so to quickly conclude, what we try to tell you today is the relevance of both Lamarck and Peirce for the contemporary biology. The notion of interpretant or interpretation has been already used in epigenetics because there is no final interpretant and the interpretation can start again and again when the external conditions allow for it. But we also think that notions such as agapistic evolution are suitable as well for the contemporary epigenetics, and habitual evolution by Lamarck, but also by Peirce, it can be reconsidered in this optic. So, and the last comment is that Lamarck and Peirce do have more in common than we would expect. They both rely on the notion of habit in their evolutionary theories, with the difference that Peirce interprets it with more teleological perspective, while Lamarck not at all. And with this, I conclude, and thank you very much.
Thank you. I'm sorry
since some part of the time saved from the previous is used up, we have just time for 6 minutes for questions. So can I see hands, please? Philip?
That was really nice presentation. And I would like to ask you, so because mention of habit in Lamarck and Peirce, now I'm a bit puzzled if like, so it's about, the word is same, of course, but in Peirce's eyes, he also like concluded that Lamarck, it's about laws, and this habit connected to use and disuse, it seems very mechanical, but Peirce's use of habit is something different, like you made this connection to agape. So what is the continuity in the use of this habit in these authors? It seems to me now that it's a bit different, but maybe I was just puzzled by something.
If I may say, I think it's different in terms of teleology, that actually where Peirce uses habit, Lamarck would not agree with the habitual evolution in terms of teleology, but he uses habit in this rather mechanical sense in terms of organisms reacting to the environment and creating habits, but it does not have this teleological dimension, I think, but the term is similar.
Peter?
Yes, very interesting. I'm going to Bateson, going to
Peter, your voice is interrupted.
Bateson was. Can you?
We cannot hear you.
Oh.
Well, your mic is on, but there is some interruption in the...
Interruption in the mic?
Okay, can you repeat your question?
Sorry?
Okay,
yeah.
continue.
Can you continue? Habit is the question. And Bateson, in his essay on alcoholism, showed that habit can also be dangerous as well as being an ongoing way of doing things. And he suggested that the change for habit or good habit or evolution would be altering of relationships. That's what Alcoholics Anonymous does to cure those people who drink too much, change the nature of relations. So I don't think Peirce does that.
Well,
Sorry,
I don't think, if this was a question or comment, but I don't think that Peirce attributes such qualities as positive or negative to the notion of habit. I'm not sure about this. Like, of course, it can be negative. I totally agree with you.
But if I may comment on this alcoholism thing, actually within this paradigm of the organic memory, it was reflected in all kinds of scientific branches, and also in criminology, and this habitual evolution, like some sorts of features, human features, cumulatively increasing in the human population, was something what explained decaying of the civilization, like in terms of alcoholism or criminal behavior and stuff like this. So it can be connected to habitual evolution very well as a negative example. It was an explanation of degradation, actually.
May I give the last question to Jamin, and I would kindly ask Andre to, well, how do we do it? Is there a breakout room, or can questions be asked during the...
There is a breakout room.
Beg your pardon? Breakout room?
There is a breakout room.
Okay, so I would kindly ask Andre to ask questions, his questions in the breakout room. So Jamin, please.
Okay, thank you so much for this paper. I think that this is a topic that really deserves extensive discussion. I want to suggest a chapter that I published in Biosemiotic Perspectives in Language and Linguistics, and in the Biosemiotic series, Velmazova, Cole, and Cowley, deep congruence between linguistic and biotic growth, where I'm trying to develop some of the same questions, which I think they really deserve a lot of extended discussion. One quick question for you in this context, perhaps too big to follow up on, but just in general, possible homology or maybe even isomorphism between teuchasm and ecology, ononchasm and phylogeny, and agapasm and ontogeny. And I know your paper was mainly about the ontogenetic or agapastic side of this equation. But so I would especially ask about that possibility between what we tend to discuss as ontogeny, not just at the level of individual growth, though, also at the level of the growth of what Peirce would call concrete reasonableness within the population, as being a major factor in driving evolution that's accepted in biology, but not mapped on to Peirce's agapasm in much detail. So what do you think about that connection?
Thank you very much for your suggestion. I will definitely read that chapter by you. About your suggestion to apply this triad of anancasm, teuchasm, anancasm, and agapasm to ecology, was like that, phylogeny and ontogeny. This is very interesting. We, to be honest, we didn't discuss it with Jana because this is really beyond our scope for this presentation. But I think that I can see your point, and I think that we can develop on that maybe in the future. That is really an interesting suggestion. Thank you very much.
Great, thanks.
Okay, I think we have to conclude this session now. Those of you who want to discuss it further, you can enter the breakout room if it's already there.
Yes, I will make the breakout room now. Yes, Yammer.
So thank you to all of the speakers and the question.
Thank you.
Thank you very much, Yammer. And since everyone's been so good keeping on time, we can have an extra 5 minutes in the breakout room and have 20 minutes now. So we'll come back at 5:05. Then we'll have a little extra time, and we have an extra time for discussion today too. So enjoy your breakout room. Anyone who needs assistance getting in, just say so, and I will put you in. Otherwise, please self-assign.
Don, I think I'll need help.
Okay.
Me also. Me also.
Okay, hold on. To make sure that it is open and going. Okay, who is the first one who asked for help? Who asked?
Your former student, John.
My mentor, my professor. Yes, teach. I'll get you in there. I'll meet you in there. See you, John.
See you.
And also me, Don, please.
Okay, Jana.
I always take breaks, so I've never been there.
I'm going to jump in myself.
Can I also go to the breakout room without sharing my screen with the countdown? Because I wanted to hear the
Ludmilla,
question.
you should. You absolutely should. It was such a good talk. You should go in. I'll take care of the countdown, or we'll have no countdown.
Okay.
Something. Go.
Well, they know when we are starting, so thank you.
I'll yell. I'll come in. Okay.
Okay.
So can you do it yourself, or here I'll assign you? Bye, Ludmilla. Who else wants to go? Ludmilla, did you not? There you go. Who else needs to be sent to your room with dinner? No one? Okay, good. All right. Sorry I cut you off before there, Peter. I had to keep on to the time here.
Don,
so
can you
want to go in?
Please put me in the breakout room.
Dan.
Thank you.
Go in? Yeah. Peter, do you want to go in?
Me too. I cannot find the button.
Okay, do you want to?
No, thank you. I need to take a break.
I know how that is. Okay. Okay, Joanna.
Don, I'm not a co-host right now. I'm chairing the next session. I
I don't really need to be a co-host, but
Yeah, I asked Dan, let me go contact him. I'll go off screen for a bit. I'll try and contact him. Tori, keep an eye on your.
I'm here.
Dan, okay. Can you give Tori co-host?
She don't want to be, okay, you don't want to be host.
Oh, is that it, Tori?
Yeah,
you don't want
you
to?
want to be. You want to be co-host.
I don't need to be, but yeah, please make me.
Yeah. So you are now a co-host.
Thank you. You did that before, but I just.
Magic. Okay. Fine.
Okay. Thank you, Dan. Always keeping us on track.
Yeah. What a team we are, Don.
The best. Absolutely the best. I'm going to take 11 p.m. Drink of water. I'll be back.
Hi, Tori.
Hi there.
How are you?
You're going on right at 11 o'clock my time. Where are you right now?
I'm in Boston, Newton.
So it's 11 o'clock.
I think it's 11:05 because he gave 5 more minutes for the breakout.
Oh, did he just now? I didn't realize. So
yeah, that's right. Is that okay, Peter?
Yeah, sure.
Right.
I mean, we're a little bit looser because of that canceled talk.
Yeah,
perhaps
it's good.
Okay.
It adds some time for discussion.
Oh, what talk was canceled?
Tori, I thought I told you. Okay, Nicole Rossumuth is canceled. Boris and Joanna jump up to 6.
Okay.
So the program is Peter, Michael Jacob, Boris, and Joanna.
Yeah, it'd be more like 6:05 because of the 5-minute difference.
Right.
And
okay, Tori?
All right, yeah, I can.
And then Boris and Joanna in an additional 5 minutes to their talk.
Okay. All right.
All right.
Dawn, please move me to breakout as well.
What's that, Philip?
Could you please move me to breakout room as well?
Yeah.
Usually I saw it, but this time I
all you gotta do is hit the button that says join is all you gotta do.
Yeah.
The room 2 join.
Okay,
anyway,
it's here.
Okay. I might pop in myself. Let's see what's going on there. Back in a minute.
I'm going to just test the share screen. Is that okay?
Yeah, you want me to help you with that?
Can you see that?
Yeah. Do you know how to share a portion of your screen so if you need your presenter's notes?
I don't need presenter's notes.
Okay.
So is that working? It's in full screen mode in PowerPoint.
Yeah, you can hit play, and so that we only see your slide and not the things on the side. And it's up to you. You want to do that?
All right, good. I'm good. Oh, I should share computer audio, I suppose.
And are Boris and Johanna, they're I guess in the breakout room, but it seems like no one's having any trouble sharing screen.
Yeah. There's always there are always unforeseen glitches and things. I ritualistically rehearse, the audio and the video before I do talks.
Yeah, I always plan.
Something always comes up.
Yeah. I guess we all got used to this teaching online.
I'm going to probably use up most of my time. So I have a timer of my own here in front of me.
Do you want to use more than 20 minutes or?
Yeah, I may go the whole 30 minutes actually.
Okay, and then you'll just, won't take questions and.
Yeah, I think it'd be better to have the discussion in the breakout anyway.
I don't know that we're having a breakout because it's the last session of the day.
Okay. Well, we'll see. we'll see how it goes. Maybe maybe there could be a little bit of discussion. If we don't have this other talk, maybe there's more. Maybe there'll be a little bit of room between talks.
Right. Yeah, I do have some wiggle room, so I'll keep that in mind. And I'll let you know when it's 25 minutes up, and so you know you have 5 more minutes until you're at the 30-minute mark, and then we could spend a few minutes on questions since we have that extra time. If you want to do that. Okay. Good.
Yeah, I rehearsed the timings 2 or 3 times, so it's going to be close, but I can do it. So.
Okay.
I always try to say too much, I think, for better or worse.
Hi, Tori. This is Michael. I'm be right after Peter. Hi, Peter. Michael Jacob. Nice to meet you.
And is Parham presenting today too with you?
Parham and Terry are going to probably sit out until question and answer time. I think it's just such a short period of time, so we'll just go ahead and I'll give the presentation and they can assist with questions.
Okay, but they're here today.
They should be. We'll see.
Okay.
I know Terry had the links. Pretty sure Parham did.
Don't see them yet.
I'll send them a kind of a reminder email right now. And my presentation will probably be about just a few minutes after 20 minutes. So something on that order of magnitude. I'm going to shoot for keeping some space for questions.
Would you like me to let you know when you're at the 20-minute mark?
I have a timer that's running when, with the notes. So probably, unless I'm at like 25 minutes, maybe you can let me know then if I'm somehow like completely lost track of time and space.
We both have timers, so you really don't need me.
What's that?
You both, Peter and Michael, both have timers, so you really don't need me.
It's different when you're in front of your computer.
You might not look at the timer though, because you get kind of, focused on your work and what you're saying. So
yeah, happy to have the interruption. Is not a problem.
Oh, I hate it though, because you're just about to finish. You're
right. And
it's going 5 minutes, and you get all yeah.
Right. What was I saying?
Yeah. Maybe I'll do this instead. And you might be, probably I will be at the side of your screen because I've been speaking recently. So you might see my hand rather than hear the interruption.
I think I can actually even drag your video to make it like prominent next to my video, like so that, because otherwise there's, 25 little squares in that corner. So.
With this side-by-side view, then there's only like the 4 most recent people who have spoken that are on this, you got the slides here and then the gallery view. Okay, so we're not starting until another 7 minutes, right?
Yeah. 6.
And Joanna, would you like me to let you know when you're at the 20-minute or 2 minutes to 20 minutes or no, at the 25-minute mark or something like that? Because I know you two are taking 5 more minutes.
Yeah.
When would you like me to give you a reminder?
Perhaps 5 minutes till the end. So like after 20 minutes, that's probably Boris will be speaking. So.
Okay.
So it's fine. I think, yeah, 5 minutes before. Great.
Hi, Joanna. I don't know if we've met.
Yeah.
I don't remember if we've met. I told Howard about this meeting, but I don't know if he's probably not tuned in.
I think we've met at Connecticut when there was a session for Howard. Were you there?
UConn?
Yeah.
Yes, that's right. That's right. Yeah. Now I have some recall of that.
Yeah.
Yes.
So where are you now? How are you doing?
I'm in Boston. I mostly retired from teaching, but I'm teaching courses on, I've been teaching courses at Boston Conservatory in Berkeley on neuropsychology of music and also consciousness studies. So some of what I'll talk about today, I've been teaching in recent years.
Super. Have you seen Dennis Waters' book?
No, I need to order it. You mean on lichens?
The one dimension. It has.
I think it's on lichens.
No. It's
new one.
Well, it's from 1 year ago, maybe.
Okay.
Yeah, I'll send you a link. Or
it's hard. This is Ecorarum Publishers.
I don't remember.
It's hard for us to get those books here in the U.S. They don't. You can't buy them via Amazon US and so there's you have to wire them money, and it's a process.
Okay.
I bought the book by Bernard Scott on past papers. They have a lot of interesting stuff, but it's too bad in terms of the ordering. But I'll look for that.
Okay.
I'll write that down.
Tori, no, sorry. Where is Nora? Or no, Tori, you are chairing, right?
I'm chairing, yeah.
Okay, Tori. I think we would like to present side by side with Boris. He needs still to get here, but I will set up now so we don't get the echo and stuff. So I will just move. So we will not be sort of at a distance like Ludmila now, but we will try to sit side by side. We will see how it works. It's an advantage of being here, actually.
Yeah, if you can both be close enough to the microphone that your voices.
I'll try this now.
Yeah, it's a good idea to test it now. We have about 3 minutes before we start.
Okay. And then we can test if we get an echo there or not.
Yeah, I guess what do you do? Make sure everybody else in the room is on mute.
Yeah. Yogi, I'm coming here, okay? Because there, I think we have too much. Maybe your corner. You tested it already.
Yeah. Okay. I will call in the breakout people if that's all right.
Okay, so how is it, Tori? Do I get an echo or not?
No, you sound good. So as long as no one else in the room turns on their mic or unmutes.
Okay, great.
Good. Of course.
Are we last or one before? I don't know. And I know that Nicole Rosmanit canceled, right?
Right.
Yes.
It's a pity.
You okay with this, Joanna? Do you want to present at 6:05 or later?
Yeah, it's okay. It's okay. I think Boris is coming, so we will be fine.
He texted me, so he knows. Oh, okay. Ludmila put up 35 seconds. Very good. We have it. We might as well use it.
It's like taking off.
Exactly. All right. My own camera's messed up here. What's going on? I don't know. Some nonsense.
Okay, everyone, welcome back from break. We have 3 presentations in the next session, and we're going to begin with Peter Cariani, who will be talking about cybernetics, neurosemiotics, and neurophenomenology. Peter, you have the floor.
Hi, can everyone see that?
Yes, yes.
Okay. So I'm happy to be here. So I think this is the first time I've presented at a biosemiotics meeting per se. I'm going to talk about sort of general semiotics, system semiotics, cybernetics, mostly of percept action systems, neurosemiotics, and neurophenomenology. My view of semiotics is very general. I was a student of Paty. Semiotic systems are those that switch behavior on the basis of materially realized distinctions. Not all material systems lend themselves to descriptions as semiotic systems. And I think we're only justified in labeling a system or process as semiotic only if we can identify material vehicles of sign distinctions and their differential consequences for behavior. So I don't restrict semiotic systems to living systems or conscious systems, but we do have to identify things that look like signs and their interpreters within the system. My framework is based on sign-mediated operations, and I regard signs as materially embodied distinctions that reliably switch the internal organization. Howard Paty long ago wrote a paper on the physical description of a switch. Basically, everything follows from that. So some systems are semiotic by virtue of their internal organization and such that they show observable sign-mediated behavior, however you construe that. There are a lot of different kinds of semiotic sign-mediated processes in nature and artificial systems. Constructive functions, genetic codes, internal regulation, epistemic functions, steering, mediation of information organization, representational and compositional functions, mnemonic functions, anticipatory functions, and the ability to create new distinctions. Some of the basic ways that I use these terms: interpretation is the process of reading out the sign, switching behavior contingent on the sign vehicle presented. Meaning is the manifold differential consequences of a sign distinction for the system's subsequent state or behavior. And I regard purpose as the end state of an internal goal-seeking mechanism, so in cybernetic terms. I use representation in a non-aboutness, non-referentialist sense. That's probably why I'm not a Peircean. As linkages to sensory motor states and systematic ways of handling distinctions that are mutually exclusive. And likewise, language is a set of sign combinations or sequences to allow composition and expression of complex distinctions. There are many sources of inspiration. I'm a theoretical biologist, come out of theoretical biology of Paty and Rosen. And I found Morris's semiotics and Uxkoll's frameworks for being most useful in understanding biological and cybernetic systems. My philosophy is epistemologically oriented. I'm an operationalist. I think that there can be multiple descriptions of the same material systems that depict different aspects of those material systems. I believe in a hylomorphic framework where we have organization that's embedded in matter, and the functional properties of material systems supervene on material organization. So mind is a semiotic informational organization of the brain, and mental processes and conscious awareness supervene on specific organizations of neural activity. So I don't believe in downward causation per se, in the sense that, say, conscious awareness changes the physics of the biophysics of channels or neurons. Many definitions depend on functional organization. We can regard life in terms of either regeneration of material components or sign-mediated self-production, where codes are essential. My sense of purposive systems, again, it has to do with goal-seeking mechanisms. Agents are systems with embedded goals and autonomy of action. And adaptive systems are systems that alter their own internal signs and sign relations in order to better achieve goals, however defined. So although all living organisms are autonomous, purposive, semiotic systems, in my view, semiosis does not itself as a concept require life agency, purpose, or consciousness, even though it's involved in all those properties and processes. So cybernetics, I take the core idea of cybernetics is that of purposive systems, that you have autonomous percept action systems that use internal feedback mechanisms for steering modification to reliably attain embedded goals. And the clearest exposition of sort of the classical cybernetics, I think, is Latiel's book of 1956. In this way, even a simple thermostat can be regarded as a sign-wielding purposive system because it has an internal goal, the set temperature, and it has a sensor, and it switches its behavior, whether to heat the room or not at any given instant, on the basis of signals that are coming from those two inputs. If we think about percept action systems, or Uxco, McCulloch, and others, we can look at what are the operations that are going on within the percept action system, both vis-a-vis the world at large and internally. I developed a taxonomy in the 80s. I developed it as a graduate student. I developed a taxonomy of adaptive system, percept action systems, and thought about them also in semiotic terms. So we have sensory receptors, internal signs that map percepts to actions, and motor effectors, whereby the signs that are produced as decisions instruct, command motor effectors to take action that then influences the world. So we have this ongoing iterated cycle of events.
Your slides are not moving.
They're not moving. Oh, that's bad. Okay. Well, so I've already presented a bunch of them. Are they moving now? Can you see?
No, they're not.
Oh.
You're not on display mode.
Oh, God. All right. Let's see. It's paused.
Very interesting nonetheless, but maybe just click on them. Click on the side slide.
I'm going to reshare. I'm going to reshare and...
Reshare your entire screen. Don't just, there you go.
Does that work? Can you see it?
Much better.
Is it changing?
Well, advance it so we can see.
No, I can't advance it. There. All right.
Perfect.
Yeah. So we have percept action systems, sign-mediated sensations, actions, and sign-sign mappings. You know, in the Maurician framework, the external semantics of the internal states are given by the both by the sensory semantics, the mappings between what's going on in the environment, and we don't ever know completely about what that is, and between command states and the motor effectors are influences on the environment. Semantics, the external semantics of a system are linkages provided by sensory receptors and motor effectors. And the syntactic of the system involves sign-sign relations in the percept action mappings. And then, of course, in the environment, there are non-semiotic processes that are going, physical processes that are going on that we don't have access to except through our senses. Oh, no, it's not, oh, there, okay. So in addition to the syntactic and semantic dimensions, there's also a pragmatic dimension, and that's evaluation of behavior vis-a-vis goals and the adjustment of internal sign relations in order to better achieve those goals. And of course, one possibility is in genetic and biological systems, you have construction languages, sign languages that guide the physical construction of the organism itself. And so one can think about percept action systems in terms of these functional organizations. One can also think of them in terms of the operations, the sets of operations and their relations that comprise sensing, coordinating, and affecting. And when these operations are, they're subdivisions of this, when these operations are directed at changing the structure of the device or the behavior of the device or relations between signs, we have evaluation, which is a measurement that feeds back into the device itself. Switching, which changes the syntactics of percept action mappings, and construction, which actually physically guides the construction of the parts of the device. We can also look at these systems in terms of state transition patterns. A measurement has a different operational structure, state transition structure than a computation. And of course, this all depends on the observer's frame. But it's possible to find frames that are appropriate where you see these distinctions. And the distinction between measurement and computation comes from a semiotic analysis of the Hertzian commutation diagram, which is the structure, the operational structure of a predictive model, where you make measurements, there are pointer readings, you put the pointer readings into a predictive rule model that consists of formal rules. There's an algorithm that generates a predicted result. You compare that with a second result, and if the two comport with each other, you have a successful prediction. And if they don't, you have to adjust the model, either the algorithm or the observables that you're using. And there are correlates in, if we take these states to be the sign states in the state transition structure of this system. Rosen's system framework is basically the same. It comes from Hertz. So we can distinguish measurements from computations and also sign-mediated actions from other kinds of operations. One can build up a taxonomy of percept action systems, real, both artificial and biological. Computers don't have sensors or effectors, so they're basically isolated from the external world. They have syntactics, but not semantics or pragmatics, except vis-a-vis their human users. Non-adaptive robotic devices have sensors and effectors that tie their internal states to things going on in the world, but it's all fixed. They're prisoners of their input-output mappings. They only do one thing in every sense situation. If we make the computational part, the coordinative part, contingent on performance, and we have some way of adjusting that, then we have a trainable machine that changes its syntactics. And it's still a prisoner of its input and output domains. You have to figure out what are the features that you need and the actions that you need to solve a real world problem. But they can solve it if you have adequate percepts and actions available to you. A self-constructing system physically constructs the hardware underlying all these things. So it can change its sensors and effectors and thereby change the relationships of its internal signs to the world, the outer world. So it can change its own Umwelt in this sense. And prime example are evolutionary lineages where you're evolving new sensors. There are other examples, neural examples that we can think about in a minute. So there are types of semiotic creativity. The first is combinatoric creativity, where you have new combinations of existing primitive distinctions. So new syntactic, semantic, or pragmatic linkages within the existing sets of signs. And then you can have emergent creativity, where you have new construction of de novo construction of new primitive distinctions. And these are roughly congruent with Petit's concepts of assimilation and accommodation. So to give a a simple example, if you have a assigned system where you can make combinations, pairwise combinations of these primitives, we have a set of possibilities, but it's a closed possibility state because the number of primitives that we have available is finite. However, if we have a means of adding new primitives, new dimensions to that system, we have an open possibility space because the space of possible primitives is open-ended. There was a device that was built in the 1950s by Gordon Pass, the cybernetician Gordon Pass, which he called organic analogs to the growth of a concept. It was an assemblage, an electrochemical assemblage, where you had electrodes inserted into a network of electrodes inserted into ferrous sulfate solution. You can grow out these wire threads, and if you adaptively reward them, you can grow out structures that then can become sensitive to sound or magnetic influences. And so in this way, this system is one of the very few artificial systems that evolves its own sensors in an apparently open-ended way, because God knows what the hell sorts of things you could become sensitive to. It's an ill-defined space of possible measurements. So we have trainable machines that are prisoners of their features and actions. And we have self-constructing hardware like the PASS device and biological lineages. If we think about brains, there are many, these percept action coordinative linkages can get very complicated. The nervous system is basically a system that's specialized for sending signals and coordinating behavior, coordinating the behavior of animals, such that if you add short and long-term memories, cognitive mechanisms, anticipatory models, goal selections, emotion, attention, arousal, then these percept action mappings can become very complex. There are ways of determining whether you have the emergence of creative emergence or combinatoric creativity that have to do with how an observer tracks a system that's modifying itself or constructing itself. In the brain, a way of thinking about this is that if you have representations in the brain that are iconic, you have an iconic analog milieu, and we'll see an example of this in a minute, and you have internal sensors in the form of neural assemblies that respond to different aspects of the analog milieu, then you have something where you're basically creating new internal sensors. And you can then, and I think of concepts in these terms, and you can then increase the dimensionality, effective dimensionality of the system by proliferating new internal sensors. Now, these sorts of ideas are active in cognitive science and computational neuroscience in the forms of, I call them concept tags. They're produced by neural assemblies, but they're related ideas of perceptual symbols and semantic pointers. And the notion is that you have low-level signals and neural assemblies that then emit higher level signals that are distinct from the lower level combinations, but derived from them, that then can serve as indications of the appearance of a concept or category. And you can activate these things by means of bottom-up activation and top-down activation. And this enables content addressable memory. For example, if you think about what an apple has in common with a fire truck, right? We can access that. We know what are the dimensions of similarity, one of them being red. And we can do that very fast by inserting signals related to apple and fire truck and having each of those patterns generate the features that we associate with those, and then comparing the sets of features. So in neurosemiotics, we're interested in how patterns of neural activity realize distinctions that subserve mental functions. And central to the neurosemiotics is the neural coding problem. What are the signals of the system in the brain? What neural differences produce differences in functions? Which ones make a difference? And also in experience. So if we want to reverse engineer brains, we need to know what are the signals of the system, what is the hardware they're implementing information processing operations that then subserve informational functions. And that would give us a multi-level, and these are different kinds of descriptions, obviously. These gives us a multi-perspectival view of how we explain what the brain is doing. However, even if we understood all mental functions and behavior, we'd still be leaving out an important part of our existence, which is our subjective experience, which I consider to be as real as anything else. So we also want to know what are the relationships between the neural codes, architectures, operations, and functions, and what we experience directly. So neural coding, there are two major types of neural codes: channel codes versus temporal codes. Channel codes involve which neurons are activated at any one point, usually in terms of firing rate, versus temporal codes where the information, the distinctions are in the patterns of spikes. I'll give an example of one that I studied. There are a lot of different kinds of neural pulse codes, and they can get very complicated. And I've made taxonomies of possible kinds of codes, and they're not all mutually exclusive. But if we go into the auditory nerve, in the 90s, I worked on the neurophysiology of musical pitch in the auditory nerve, and we record from neurons in the auditory nerve, and it's a strategic nexus because all the information we have for hearing goes over these roughly 45,000 neural nerve fibers. You go in, you play temporally patterned stimulus, you see that there's tuning to particular pure tone frequencies, but there's also enormous amount of timing information. These are histograms of spike times for 100 presentations. You see that there are periodicities in the firing patterns that relate to the voice pitch, or the formant period, oo. These periodicities show up all across the auditory nerve array. Here's just more data of the same sort. Everywhere there's timing information as long as the stimulus is presented at a reasonable, even a low to high level, throughout the whole gamut of sound pressures. And what happens, the reason why they follow this is known as phase locking. The spikes don't fire every cycle, but they fire only on one part of the cycle. And that means that the spike trains are correlated with the time structure of the signal. And these interspike intervals give you the time periods, subharmonic periods of the signal itself. For some reason, it is not advancing. It's not limited to audition. In the visual system, you also see locking when you have a time varying signal. Looks very similar. So what we found is that if we take the time intervals between these spikes, and that's an iconic analog code, and we compile a histogram of the entire population of auditory nerve fibers, as we estimate it to be, from recording from 100 to 200 auditory nerve fibers, we can predict what the pitch will be from the predominant interval in that distribution, from the mass statistics of the interspike intervals. We can do it within about 0.5%, which is on the order of magnitude of our acuity for pitch. And this model works for a huge host of, sorry, I meant to do this later. There's an emergent pitch. We'll do this in the discussion if we want. There's an emergent pitch. When you add the harmonics together, you get a composite pattern. Well, we'll do it now. So those are individual harmonics. Here's the whole thing as we add them all together. So
5 minutes, Peter.
we hear just real harmonics. And as we add them together, I'm sorry? How many minutes? 5 minutes, okay. All right. As we add them together, you hear a pitch related to this composite pattern. So we can explain the vast majority of pitch phenomena based on this model, this internal representation, why different stimuli have the same pitches, even though they have very different spectra. We can explain vowels, why vowels are different. You can throw away all the place information, the channel information, and you get a perfectly good and robust, precise representation of vowels in the auditory nerve. And I've written about the implications for musical tonality. I teach courses on psychology of music, and we use music in lots of different ways. The different genres are designed for one or two major purposes: to induce psychological effects like getting us to dance or relaxing us or waking us up. And each musical genre uses different temporal and structural parameters to induce these effects. So my working hypothesis is that music speaks the language of the brain in a metaphorical sense, which are themselves temporal codes. By impressing time structure on neural populations, it drives neural responses in a manner that's sort of similar to what's going on in those areas normally, and therefore can induce the accompanying psychological states and effects. So this population interval coding scheme enables multiplexing. And multiplexing means that you can put multiple signals on the same transmission lines. And I was inspired by Raymond Emmer's work, empirical neurophysiology work, where he claims to have discovered a multiplex code for cutaneous senses. If you have this and you can mix and interleave these codes, they don't interfere with each other necessarily. You have a pattern vector mode of representation that's very flexible. I've proposed codes for auditory attributes of single musical events in the time patterns of spikes, and then the rhythmic patterns are encoded in the coarse temporal patterns of events. What multiplexing does is it liberates signals from particular elements and paths. You no longer, the form of the signal indicates its signal type. And it means then that you can have signals interacting with each other rather than having to pin down how they're going to go through various connections and connection weights in order to propagate through the network and to activate specific neural assemblies. So I've been working on, and the neural codes, the nature of the neural codes require different kinds of neural network architectures. We can rethink cortical structures in the basis of time codes and coincidence detection rather than rate codes and spike rate integrators. And about 20 years ago, I proposed neural timing nets as a different kind of neural network that takes temporally coded signals and outputs temporally coded signals to realize information processing functions. So my psychological model of faculties is that the brain is a network of loops, of reverberating pattern resonance loops, in which you have different kinds of signals in various loops. And in working memory, you have global loops that take all of these signals and stabilize them locally, but also provide a global regeneration. And so one can think about how one would have a model of the brain, a brain function based on time codes and temporal processing architectures. So this is a cartoon, obviously, but you get resonance patterns. They're sort of like what Lashley envisioned, I think, in terms of non-local interactions between neural firing patterns.
Peter, we're at the 30-minute mark now, if you can get to.
I'll wind it down. So the gist of it, so in neurophenomenology, we want to know the relationship between neural activity and subjective conscious experience. We want to know, so my working hypothesis is that neuropsychological isomorphism, organized matter leads to neural signs, which subserve awareness. And so all experiential states are due to coded patterns of neural spiking activities. The dimensions of our experience correspond to neural coding dimensions. And I have, so the best theories right now that comport with psychophysics, with what's going on during anesthesia and absent seizures and masking of percepts rely on recurrent activation. They're neural global workspace models. And basically, my hypothesis is that the contents of our present awareness correspond to those neural signals that are being actively regenerated in global loops and reinforcing each other. So more or less an autopoiesis of neural signals. I use the term advisedly, but a self-production system of neural signals. So that's it pretty much. There are some references. So thanks.
Thank you, Peter. We're going to move on to the next talk now. So everyone, please keep your questions in mind for some time afterward. And fortunately, we're going to be thinking about the same thing with brain music. So keep that in mind. Michael Jacob and Param and Terry, Michael is going to be doing the presentation. And let's see if you're moving you can move your slides, Michael. Yes, it's good. Okay, thank you. Please.
Unmute myself. So first, I really want to thank all the conference organizers for the work and putting this on and for including me today. I'm new to the field of biosemiotics, and this is basically my second gathering, but I've really become convinced over these gatherings that I've really come to the right place to further discuss these ideas. And today I'm going to describe some of the efforts that we've made through a group collaboration to develop a neurosemiotic model of brain function, including the theoretical, experimental, and applied aspects of that endeavor. As a government employee, I'm required to tell you this, but I don't think it should come as a surprise. And we have no products, patents, or business ventures related to this presentation. So I think this quote speaks to the challenge that motivates our work, this presentation, and the question of really why develop a model of neurosemiotics. And as a tool, the computational paradigm has been enormously successful for analyzing the anatomy and physiology of the brain. However, our concern is that the traditional computational model of brain function is somewhat misleading. We're concerned that the tools applied by computational neuroscience have been mistaken for the processes that underlie brain function. And over the course of the next 20 minutes or so, we'll discuss some limitations of this model and entertain a theory of semiotics as an alternative. To frame our presentation, we offer music, just like Peter, in our case, as an analogy. And of course, music can be analyzed computationally, can also be written as a code to be translated into a performance by a musician. And the question for us is really, how does this code convey the meaning of music? How can we determine the meaning of a piece of music? And we take this quote from Suzanne Langer as particularly instructive, that music has no literal meaning. It may present emotive experience through global forms that are indivisible. In short, what we'd like to explore today is if the brain, like a piece of music, presents indivisible global forms to convey meaning, function, and significance. And I don't think it should come as any surprise, especially after hearing the last talk, that we as neuroscientists have adopted computational model given the binary nature of neuronal action potentials and the binary digital nature of computer code. And it's perhaps also no surprise that, that at a cellular level, biosemiotics would also look to these same action potentials to investigate triadic sign relations by considering the neuron as the interpreter. We think this approach has potential to enrich our understanding of cellular molecular function, but may have limitations for determining relationships to cognition. And so in effect, we're asking, what is the sign vehicle for cognitive neuroscience? So first, we'll present two limitations to the more traditional computational model of brain function, focusing on the presence of ongoing spontaneous neural activity and this phenomena called representational drift. Second, we'll consider the utility of dynamical attractors as sign vehicles for neurosemiosis. We'll speculate that the dynamical attractors can reframe these potential limitations as being adaptive for brain function, particularly with respect to neuroenergetics and representational plasticity. Lastly, we'll address the relevance of the music analogy and the potential utility of neurosemiosis for understanding emotion and phenomenal experience. So first, to consider the phenomena of spontaneous activity, we'll use a toy model of a chair selective neuron. So this neuron shows a pattern of electrical discharges or a spike train that is correlated with the presence of a chair, for example, as a visual stimulus. And from a semiotic perspective, one might be tempted to call these spike trains as an index of the presence or absence of the chair. However, a problem arises when we take the chair away. The neuron remains spontaneously active, albeit with a different pattern of activity, what some have called background activity. And for some time, the neuroscience field has either ignored this inconvenience or assumed that spontaneous activity was noise. That from a traditional computational perspective would suggest that the neural representation of the chair may have been degraded by seemingly irrelevant neural activity. In fact, what has been found is that this so-called spontaneous activity is correlated across neurons, giving rise to the term noise correlations. And more than 20 years ago, work by Grünwald and colleagues explicitly examined spontaneous activity using voltage-sensitive dye imaging to visualize the activity of thousands of neurons across the surface of the visual cortex. They found that, somewhat to their surprise, this spontaneous activity was not random. It was well correlated with neurons with shared stimulus selectivity across cortical columns in the visual cortex. And moreover, this spontaneous activity matched stimulus-evoked activity in terms of the spatial distribution and magnitude. Recent work has confirmed that these so-called noise correlations increase the uncertainty of information transfer, basically Shannon information, but the same correlations are higher in animals, in this case mice, when they make correct choices in an experimental forced choice paradigm. We think that these findings suggest that spontaneous noise correlations may actually be of profound functional significance. And I think it gets more interesting when we consider a phenomenon known as representational drift. So if we return to the example of this chair selective neuron, representational drift implies that over time, the neuron no longer shows stimulus selectivity for a chair, but instead shows selectivity for a haystack, for example. And again, from a traditional coding perspective, representational drift might also suggest signal uncertainty and a reduction in Shannon information. But perhaps this drift is actually to be expected. Maybe it's a feature rather than a bug. So to illustrate this phenomena, we'll show a recent example from representational drift from the paper in Nature that coined the term. In this work, they found that in the olfactory system of mice, neurons that showed robust selectivity for one odorant changed over the course of days, shown here for 3 different neurons labeled unit 1 through 3. Each day is shown in a different color. We have wondered if this change is adaptive, a form of representational plasticity, rather than just random drift. This would be well aligned with changes in stimulus selectivity that can also occur over the course of mere seconds rather than days. Here's an example from neurons recorded in the temporal parietal junction in monkeys that were trained to perform a spatial navigation task that I conducted back when I was a graduate student. In this example, neurons that had previously shown robust selectivity for the direction of visual motion, which is shown in orange, these neurons were transformed to show selectivity for the intended location in the steering task, shown in black. I'll note that while these are averages of many neurons, rather dramatic changes in stimulus selectivity were also seen on a single neuron level during the spatial navigation task. This finding suggests that changes in neural representation need not only arise from a slow or potentially random drift process, but occur in a manner that depends on the significance of the stimulus and the behavioral context of the organism. So hopefully up to this point, we can appreciate that from one perspective, at least, the traditional computational analogy might have limitations. But of course, the brain is composed of billions of neurons. Just stepping up to the population level helps solve this problem. And we'll take up one proposed solution, that is that the activity of neurons is synchronized across the population. And this synchronized activity, which gives rise to the summated dendritic activity observed by local field potentials, LFPs, or electroencephalography from EEG, we're going to consider that at this level, we need to look at this level to identify the code or the sign vehicle for neurosemiosis. And this approach is well captured. Part of this approach is well captured by the rhythms of the brain perspective that remains highly influential today and popularized by Bujaki's famous book on the topic. And of course, this perspective has been powerful for inferring correlations between activity and frequency bands, as one might observe after Fourier decomposition, which is shown here. These frequency bands that are thought to reflect coordinated activity across specific neural networks. However, this correlational approach between frequency band activity and stimuli or task must also contend with the presence of ongoing spontaneous activity. In addition, it remains a mystery how the brain might decode frequency-based neural representations. An alternative to this approach was developed by Walter Freeman in the late 1980s when he used dynamical attractors and modeling with nonlinear differential equations. Through this work, Freeman proposed that the brain, or at least in this case, the rabbit olfactory bulb, was situated on the edge of chaos, that seemingly random chaotic attractors present in the ongoing spontaneous activity would enable formation of a new chaotic attractor during perceptual detection of an olfactory stimulus. And unfortunately, much of Walter Freeman's work has been sidelined, or at least became subsumed by this question of whether the brain is truly chaotic. Recently, the nonlinear modeling approach using differential equations has been revived by researchers such as C.J. Stamm, Michael Breakspear. We want to draw a subtle distinction between the approach, that approach, and the methods that I'm going to outline now. In Freeman's work, and in many current modeling efforts, the presence or absence of dynamical chaos is built into the nonlinear differential equation modeling. By contrast, we remain agnostic as to the precise application of chaos theory to brain function. Instead, we utilize the methods of dynamical phase embedding to qualitatively and quantitatively explore nonlinear brain dynamics. We borrow methods and terminology from George Sugihara, who developed empirical dynamic modeling as an equation-free approach to investigate the dynamic structure of multiple ecological time series. The empirical approach generates a so-called phase portrait of a time series by plotting the time series against delayed copies of itself. Here, the three copies are shown in red, green, and blue, and then plotted in 3 dimensions on the manifold. Here, in this short video clip, you can see how this approach, known as embedding, recreates the dynamical trajectory of activity, maybe even a possibility space, if you will. This approach captures complexity and redundancies that is not obvious in the unidimensional time series. And as we hypothesize that these dynamical attractor portraits serve as a sign vehicle for cognitive semiosis. So thus far, we have presented a couple limitations of the traditional computational model and introduced the concept of a dynamical attractor. Now we provide a very basic overview of the utility of the attractor approach for neurosemiotics. Excuse me. First, to say a few words about dynamical attractors and how we conceptualize them as iconic motifs. On the right, we show an example of a dynamical embedding rotating through 3 dimensions This is of an EEG signal recorded from a human participant resting at rest in our laboratory. There's no task. Note that the attractor displays quasi-regular spatial temporal patterns. That is, it shows more complexity than a simple oscillation, but the activity is not random. It's more like a rough whirlpool. The redundancy in form likely results from highly recurrent circulations through reentrant cortical anatomy. And we can develop some intuition for this recurrent activity by visualizing the formation of the attractor in time. Here, plotting a slightly different attractor in time in this short movie clip. And we can see how it fills in. We hypothesize that ongoing activity and resultant dynamical attractors form the interpretive context against which all incoming signals are superimposed or compared. Rather than simply reflecting synchronization through frequency-based phase coherence, we see these attractors more like a musical motif. New signals might show relative consonance or dissonance based on shared form with the ongoing activity. Lastly, our implementation of we implement attractor dynamics and suggest that this suggests that ongoing activity is neither spontaneous nor noise. Ongoing activity in the form of an attractor is not spontaneous because it requires metabolic energy to initiate or to change. And this recurrent and redundant dynamics may also be energy conserving, something akin to momentum or inertia that makes habit a potentially more accurate description of brain dynamics. Of course, this approach is highly speculative, but we propose that iconic interpretation occurs via a resonance process among attractor motifs. And I'm going to outline that here by taking an overview of this process through perceptual system. The hierarchical nature of the perceptual system, such as the ventral object processing stream shown here, illustrates how different brain regions or populations integrate essentially iconic features of stimuli into a coherent representation. We consider that population biases, what most neuroscientists might call response properties that give rise to a population representation, are actually plastic habits formed from ongoing activity during development. We propose that it is this ongoing activity that supports iconic interpretation. Basically, we hypothesize that ongoing activity dynamically represents perceptual information in the dynamical nature of the ongoing activity and not any particular code or sequence. So attractor motifs.
4 minutes.
Attractor motifs from two connected brain regions may be more or less resonant. This resonance is based on shared form or iconism in the attractor structure. This resonance in attractor iconism might also mirror stimulus level iconism within traditional functional streams to give rise to a coherent percept. This proposal suggests how, for example, auditory activity could influence So we suggest this proposal suggests how auditory activity could influence visual activity through cross-modal iconic resonance that is solely dependent on the shared dynamic structure and not any particular stimulus representation. The widespread presence of cross-modal visual illusions, experiences of synesthesia, in addition to novel plastic adaptations after function loss, such as deafness or blindness, would further support the relevance of our hypothesis to the idea of representational plasticity. And we suggest that iconic attractors qualitatively capture the immense dynamic complexity of stimulus processing. Furthermore, this approach does not preclude quantitative or statistical approaches to data analysis. And we have begun to explore more statistical methods using empirical dynamic mapping, using nearest neighbor methods to determine iconism between attractors and their mutual influences on each other. And of course, we don't expect that the brain is limited to iconic interpretation. And at least part of the power of the semiotic approach is in the potentially nested relationships between interpretive frames. By expanding the combinations of modular attractors to more complex networks, we can begin to look for evidence of higher order semiotic interpretive processes. And we don't have time to get into this now, but just to give some sense that, that how we might complexify this model, that these networks might bridge across diverse motifs. And we begun to speculate that it's actually the process of attention that enables temporal correlation of attractor dynamics, which need not necessarily share iconic resonance. These correlations might serve an indexing function, scaffolding upon lower order iconic relationships. So from a neurosemiotic perspective, at least in our model, we consider brain activity to be more akin to the development of a rich musical composition out of an incessant habitual stream of signs. And we think this approach is consistent with Peirce's perspective on cognition when he said, thought is a thread of melody running through the succession of our sensations, just as a piece of music may be written in parts, each part having its own air. So various systems of relationship of the succession subsist together between the same sensations or feelings. These differences are distinguished by different motives, ideas, or functions. So in closing, we'd like to just make a few remarks about emotion and phenomenology. We feel that the connection between music and emotion proposed by Suzanne Langer at the outset of this talk can be directly related to the function of the brain. Brain dynamics literally present felt emotional experience. This idea might explain why emotion has a particular dynamic feel and why it's linked to embodied physiology and metabolism in particular. In short, we consider that a neurosemiotic sign is a dynamical trajectory of ongoing neural activity and the metabolic energy involved in sustaining or constraining those dynamics. In this light, we take a much broader definition of emotion than is traditionally used, one to include all felt experience, the experience of physiologic energy in motion. Similar to music, the brain presents emotive experience through global forms that are indivisible, what we've called dynamical attractors. These theories have implications for experimental methods that we're beginning to explore in order to examine interactions between simultaneously recorded neural and metabolic signals. And lastly, this approach has implications for clinical psychology and psychiatry. As a psychiatrist, I found the computational analogy for brain function seems to undermine my patient's sense that they're living organisms. Thus far, I found that a musical analogy may provide an alternative formulation for mental illness and mental life, one that feels like a closer match experientially. So in summary, I'll present this table, which illustrates how basic and experimental observations can be reconsidered from a neurosemiotic dynamical lens. In the case of ongoing activity, rather than being noise, we consider this activity to be the interpretive context which must be supported through extensive metabolic input. The paradox of representational drift can be reframed as a biological process to support online adaptation or adjustment, something to be expected. That is a feature rather than a bug. And lastly, we speculate that the attractor perspective can capture the dynamic feel of phenomenal experience as fundamental to all neural dynamics. And we hope that our approach will enable new avenues for research in embodied neurocognition and neuropsychiatric illness. Of course, I want to thank all of our collaborators across San Francisco Bay Area, beyond, our sources of funding at the VA and the Kasira Foundation. So thank you very much.
Thank you, Michael. And I think we have about 7 or 8 minutes for discussion afterwards. Parham and Terry, you're here too, so you'll be able to respond if necessary. We have Joanna and then Peter.
Yes, thank you, Michael. That was really wonderful and seems really very plausible, which is something that we look forward for the developments. I have 2 questions. First of all, the dynamical attractors can be reconstructed in multiple dimensions. That's their feature. And how are we going about finding those dimensions? I know that there are methods like RQA, recurrence analysis, for example. So do you advise to use those or some others? And the other, another question is, your approach seems very perceptual. How are you going to connect it to more action-based accounts? Thanks.
Thank you. Excellent questions. So the first about the dimensions and the attractors. So I skipped over most of the methodology that we employed in terms of embedding. And at this point, we've considered a couple approaches. One comes from Joe Sugihara's work using empiric dynamic modeling. And in that case, it's based on basically embedding the attractors in as many dimensions as possible to see where you sort of kind of max out in terms of something like mutual information or some other measure. More recently, we've adopted some models using from work by Steve Brunton at University of Washington that makes use of principal components analysis to try and do some dimensionality reduction on the initial manifolds. And some really interesting work there that then actually enables differentiation between the linear and nonlinear aspects, or at least what aspects of the attractor could be modeled linearly or predicted from a linear regression model. But we're still working on all of that. So no firm recommendation on what's the way to go there. And then a great point about perception and action. I think, I don't have a ready answer for you, but the one that seems to stand out most in my mind is what's influenced me in this work has been Terry's countercurrent model, in which case really the perceptual stream and the action stream, they're going to have very similar underlying neural architecture. And I think that therefore pretty similarly underlying dynamics, such that ideally we could map either of these processes in either of the domains. But that the other thing to say is, right, I think that anything we're looking at, any of these attractors, while I'm using the language of perception, action is happening the whole time as well. So it's not really to say that it just tried as a way of simplifying it. I focused on perception, but the attractor itself is going to be shaped by whatever the action intentions, plans are. Even if you're just sitting and lying there at rest in the brain scanner, you're going to have, I got to lie here still. And so that's going to affect the shape of the attractor. So I don't think I think it's probably both.
I think these are perception action attractors, by the way. Yeah, thanks.
Peter, please.
Hi, thanks for that nice talk. There are different ways of looking at brains and all the way from sort of underlying dynamical systems to symbol systems of the cognitivists. And in the middle are these mid-level neural representations. And the advantage of the neural representations over something like the dynamical systems and attractor basins is that you find the invariant dimensions that correspond with perception. There have been dynamical systems models of olfaction, but they don't get you the low dimensional, as in E.G. Boring's treatments of percept spaces. They don't get you the dimensional structure of the percept space. So I have a lot of other comments about feature detectors and multiplexing neurons and things like that, and we should talk sometime. But thank you for that talk.
Michael, did you want to respond, or do you want to hear Don's question first?
Well, go ahead. We can go on to a question. I can make a comment, but why don't we hear the next question?
Okay, Don, please.
Okay, great. Really fantastic. And it's so interesting to see the overlap between Josh's work, your work here, and even what Peter talked about, because you all decided to come upon this notion of resonance among many, many, many dynamic systems and the attractors that will emerge from them. So my question becomes, if you want to address this kind of very briefly, how do you see your view of this as being different than what, say, Josh showed us yesterday about structured noise and the emergence of refinement? coming from all of these signals that are interacting with each other and grouping together and coming to higher order dimensions of relationships with each other. Because certainly if we are going to understand semiotically, that's what we're trying to understand, relations and their interactions and interrelations. So this is great model stuff, and it still opens up the whole question of, all right, what are these things? How are we going to understand them semiotically? But because it seems like intuitively seems like such a right model, right? That the interpretant is a subset of a real possibility space and is a signed vehicle and is an object. And when they come together, you have this unique relation. So again, the question that I would like to ask you is, how do you see this as being, where does this fit in both Peter's ideas and Josh's ideas?
That's I was going to take. I'm probably going to need a few days or a decade to figure that out. But I'd say Josh and I have had many conversations about this, and we have the advantage of living nearby. And one thing that I'd say is that Josh and I have continually returned to the idea of structured noise. And I think that you probably picked up on some of that in my presentation, just the importance of ongoing activity, what is noise and sort of what is signal. I think one thing that didn't get a chance to emphasize that I think probably also relates to perhaps even maybe to Peter's question is the importance of what's in that milieu. And I think we've taken a neurocentric approach a little bit, and I'm guilty of it as anyone, being a basic neurophysiologist by training. We've ignored all of the glia, the blood, the oxygen, the metabolism that's in that milieu that is kind of contributing to that structured noise that is going to influence the signal. And so I think that I'm drawing on the ideas from basic sort of cellular models that have identified this, but then now we're trying to use simultaneous recordings of the metabolic activity and neural activity to sort of get at that question. It's really about trying to understand maybe some of the code duality and the analog signals that are in that structured noise and what that's about. So it's not a precise answer to your question, but maybe the direction I would go to frame the conversation.
It's a great answer. Terry, did you want to say something about that?
Mostly to add that a lot of our current research is literally about the role that metabolism plays. It's interesting that the computational model is a model that treats energy as a constant. It's a background. It's in a sense a context that we just assume is there. Just like we do when we talk about a computer, we don't worry about whether the energy is going up and down in different units and so on. We just keep it constant. In the nervous system, that's not the case. In the nervous system, first of all, every cell is alive. Every cell is being pushed around. Its metabolism is being jiggled with, so to speak. The exciting thing about the attractor approach is that it fits with dynamical models of self-organizing processes, in which to understand how attractors form in physical systems, energy is an intrinsic part of it, as energy passing through a complex network in a physical system or in any other system. When you push its energetics dynamics beyond an equilibrium, so it has to, in a sense, offload that dynamics as fast as possible, things become more organized. Constraints build and recursively structure each other and produce attractors. And so one of the things that by looking at the brain in terms of not just the signal processing, but looking at the brain as a dynamical system that has an energetic feature, it changes our whole perspective. And when Michael ends by talking about emotion, a lot of what we're talking about is, says, why is there a feeling to things? Why is there a sense of things in every aspect of mental activity? And part of that is because there's a feel to it. There is an inertia to it, a kind of energetic inertia. Attractors have an inertia. And they have an inertia that has to do with the energy going in or out. Driving the energy up changes the attractors, pulling energy down changes the attractor structure. And of course, we've got these sort of two ends of the spectrum to look at. One end of the spectrum is the fMRI, which is telling us about the energetics unfortunately, it's slow. We have at the other end of the spectrum the ability to record from neurons or to look at EEG very fast. We now have to find ways to put these together. And part of the methods that Michael was talking about are attempts to bring these two together to understand the dimensions of the energetics in the signal processing.
Right, because when you're looking at single neurons, you're missing the big pattern activity. Looking at pattern activity is like looking at the moon from here. We're going to have a great after talk, I think, after these 3 sessions. So thank you all very, very much. All of the presenters are doing great work on this.
We're going to have some time to talk about all these talks together. We're going to move on now to Johanna and Boris. If you want to share your screen, I don't know which one of you is going to. Oh, there you go.
Hello. So first of all, let us thank you guys for organizing the conference and for having us here. Actually, Nora, Daniel, and Johanna, everybody is so welcoming. And I know that it's a nuisance to actually coordinate a hybrid conference. But it's really, we are so grateful that we can see each other face to face. And here are 3 people, you can see it probably, sitting with us in the room. And I'm sitting with Boris. And we are able to present at the same time, which is something that we missed so much, right? And let's keep our fingers crossed for next meetings face to face. So today we wanted to tell you about a sort of experiment. First, let me. Well, it will. Thank you for the previous presentations. Come here. Come. we are here together. So thank you for the previous presentations because actually we are striving for dynamic vehicles as well. So this is something that connects our talk to yours, the previous ones, but it will also be very, very different. And why? Well, we represent something that is called Human Interactivity and Language Lab. This lab strives to study language, but on the basis of human interactivity. So as an emergent system that guides this activity and also strives to make the study of language actually a little bit more humane. And that means that we are trying to build bridges between cognitive, language, and human sciences and integrate perspectives. And this is perhaps because I'm getting a little bit old and I stopped being militant at some point and recognized that, hey, yeah, really, that, hey, people believing in, strictly generativists or structuralist models, they are good people, they want well. And actually, okay, they might be a bit wrong from some point of view, but they are realizing some values as well. And so these are those multiple circles or drops of water that showed up so many times. And also in Tyler's talk, it sounded so strongly that we need intertextuality. We need to bring perspectives together, right? So we try to recognize values realized within each approach, contextualizing them and working together. So here's Boris, and Boris is an analytical philosopher, right? So somebody who probably, there are not many analytical philosophers in this room. But nevertheless, I think we strive for similar things. We build connections where my background is in ecological psychology. So for me, of course, Gibson's approach to how we perceive the world within acting and how we actually do not have to worry about time because events that we are engaged in actually define our time or make it. And also seeing the world already in terms of affordances, which are immersed in actions, like Merleau-Ponty would say that we are engaged right now and right here in multiple projects. So every object that we are looking at has this inherent intentionality in it. And of course, engaging also with an activism, people like Hanne de Jager, whom I mentioned yesterday, the one that writes about love, and Ezequiel Di Paolo, who are in turn doing something that ecological psychology is not doing enough. And I think semiotics is not, and biosemiotics is not doing enough, namely to look at our experience, something that Terry mentioned right before, a couple of minutes ago, that we have a particular perspective. This is great in biosemiotics, it shows, but each perspective has a little bit different experience and how to link them. So also we try to engage the mainstream, the symbolic processing, and those people that we were always offended with and militant against, but now, hey, they are so successful. And how, you know, if you are talking about symbol processing, then, well, it does look like symbol processing in some cases for some people and for some reasons, and they are so successful. For example, in automatic translation, this is really dangerous if we do not know how come they are so successful and which values are realized in their approach when they are so successful. So of course, and we ask ourselves, how on earth processes can look like symbols that you can manipulate according to computational models and rules, and which values you are losing when you are making something computational and which values you are actually accentuating, right? So this is what we work on the daily basis, is biosemiotics of language, biosemiotics of language, just like Taylor was saying, that this is really something that we want to go deeply. We don't to remain on this semiotic sort of literary human sciences perspective. We do want to extract language from biological basis. And so for us, language is a system of constraints over interactive dynamics. This interactive dynamics is extremely important. Do you see my mouse? Yes. So here we have, and we do it in language development. So, you know, a baby does not know what a symbol is really, and there are no free floating symbols for babies. Babies have utterances, voices, movements, emotions, objects. This is all they perceive, and they perceive them in many multiple, very intricate relations. And what happens during
You got muted.
Boris, could you unmute? We can't hear you.
Okay.
Is it live?
Yes, it's okay.
When did I get muted? What did I say last?
Right after you said babies have objects, they have noises, and what happens is.
Okay. So what happens is actually that among those movements and actions, there is a vocal layer that is emerging. And what we do research on is this, is this graph at the bottom, where you see actually a method that Michael was talking about, recurrence analysis, but applied to mother-infant interaction to show how the vocalizations get coupled and get their turn-taking structure. So we do have this symbolic sort of layer, not yet symbolic, but this miracle happens, that out of the events, out of the actions, there is a layer that is emerging that we at some point can call language, and that within which we start to perceive novel relations. So this is our background, and actually, sorry, I'm something with this that it blocks my screen. So we are using here the relations between the dynamics and symbols that are sort of suggested by Polanyi or Howard Patti or for Neumann, that you actually need both. You need this dynamical side and you need the symbolic side. And unfortunately, I won't be talking about this because I have Boris with me here, and he's actually doing some discoveries on our behalf as an analytical philosopher who is also sort of, I think, frustrated, can I say this, with the lack of dynamics in the analytical philosophy. And he found this really interesting Polish semiotician that he would like to tell you about. So Boris, the floor is yours.
Hi, now I can show myself. So as Joanna was very kind to disclaim, I come from an analytic philosophy background. So please do not be offended if I say something heretical. And keep in mind that even Pope Gregory, who started the Catholic Inquisition, was sure that heresy lies in persistence and not in mistakes. So I hope you're happy with that. So first of all, if I am able to change the slide. That's not my slide.
Yeah.
That is my slide. So first of all, I'd like to walk you through the motivations for having events as a foundation of an ontology of science. And then we have a look at a few properties of events in general, just to make it clear how they differ from objects. And but first, let's talk why. So it is well known that objectism, if I can say that, well, has its problems. It's plenty of problems. And I'm sure you know this anecdote about Winston Churchill and his recipe for a drink, a martini. So the story goes that Winston pours himself a glass of gin, and he picks it up, swirls it, and whispers vermouth over it. And then that's it, he has his drink. So I think it's a bit like that with objects. If you really stubbornly committed just to objects, you basically end up with a glass full of stuff and you whisper causation over it and you hope for the best. But all you really get is really drunk, and it doesn't really help with much. So so it is trouble, and unfortunately, it is especially visible in fields that study cognition and communication and consciousness, and other fields where we have to deal with the, well, sad for some people, reality that you actually have to deal with subjects, dynamical subjects who also have agency. And so it happens that this is exactly the predicament of biosemiotics. So when we limit ourselves to substance and maybe a bit of causation, we end up struggling with seemingly simple things, like what is time in action? And how do you describe causality? And is there some, if you're a Gricean, for instance, how do you account for natural science without having sort of a double standard for intention? And there's also some experimental evidence that has to be, explained in terms of objects, often painstakingly explained. Like, we have parts of grammar that are designed just to say what happens, like verbs, or the findings that we have of how children learn how to speak. So, all of these look like good reasons to consider an alternative. And the good news is we already talk the language of events. And here I allow myself to read a little excerpt from an article by Casati and Varzi from the Stanford Encyclopedia of Philosophy, which I think is very pretty and pretty convincing to anyone who's not a philosopher even, that there's something here happening. It's not just matter. So Casati and Varzi write, it is smiles, walks, dances, weddings, explosions, hiccups, hand waves, arrivals and departures, births and deaths, thunder and lightning. The variety of the world seems to lie not only in the assortment of its ordinary citizens, animals and physical objects, and perhaps minds, sets, abstract particulars, but also in the sort of things that happen to or are performed by them. Indeed, there is little question that human perception, action, language, and thought manifest at least a prima facie commitment to events. And I think that's more than enough to try this path. So in plain English, how do events differ from objects? Well, first in how we talk about them. So we say that things exist, but events can only occur. And this is an old terminology. It goes back, well, way beyond Creswell, but Creswell was probably the most known one who did some systemical work on that in the 70s. Then another difference is in how they appear in the world. So things, we tend to say that things are more defined in space and less defined in time, and events are more defined in time and less in space. And these, of course, are not absolute distinctions, but it still seems that objects have a monopoly on space they occupy, while events do not. We can have very many events happening in the same place at the same time, which is definitely this kind of difference. And finally, there is a difference in how these two types of beings persist. So it seems that things usually are believed to exist in its entirety, and they then just disappear or break down as an object. And events unroll in parts that disappear very quickly. So each of the parts of an event appears, is realized, and disappears, and so it goes. And yet still we consider it one event. So these are like easy ontology arguments that there is something in there that we should take a look at, even though it goes against some very influential philosophers like Russell, Quine, Lewis, who rather see objects, especially Lewis, as sort of a spatio-temporal worm that travels in time. But I'm sure it can be explained in some kind of event too. So let's not go into that at this point. So another reason to do that is that researchers in other fields already use them with quite a lot of success, like in logic and semantics, where Barwise and John Perry developed a theory, a situation theory, which treats events as construed sets of functions from spatio-temporal locations to the situation times, which are sequences of objects standing or failing to stand in a certain relation. The theory has found many uses outside semantics as well, also in some interesting fields like workplace research and interactions between people. And also ecological psychology finds events pretty well equipped to serve as the basis of perception, but more on that a bit later towards the end. So with all of these motivations and potential of event-based ontology, the question is, why are we not using it for semiotics? And that was, of course, a rhetorical question, as you probably guessed from the title of the talk, because we do use them in semiotics. And the hero of this talk is this Polish logician. He's relatively forgotten, Leon Koy. And he worked mostly in Lublin in the 20th century. He was primarily focused on logic and semiotics, but from the analytic point of view, which is not surprising. His, from all I know, last book, because he died in 2006, introduced this idea of a processual account of science. So Koy's event-based semiotics is sort of a simple idea taken a long, long way. And the assumptions are few and pretty easy. And let's look at it. So here, as you can see, and this is the simplest formulation, which is only a beginning. So a sign is sort of a relation. It takes a user and accompanying events in time. It has 6 variables, 2 name variables, 4 propositional variables. And as you can see, the very basic approximation of what it looks like on the screen. So this is this Z thing. And the formula in normal English sounds like that in a time t for a person V, that's P, a proposition refers to that Q in context S, and for a goal R. And I think we can interpret this, at least the 4 parts of this weird statement as a kind of interpretation in the Peircean sense. So when you collect the time, the context, so like the event that is accompanying the utterance, and the goal and the person, this is sort of, I think, Peirce meant when he talks about interpretation of a sign. So it is essentially, if you squint a little one eye, a more nuanced, context-sensitive formulation of intention with an S in analytic philosophy of language. So a way to get from utterances or from symbols to different meanings in the world depending on the context, but it's more rigid than doc here or usually in biosemiotics. or even Husserl's Bedeutungsfunktion, so just the meaning function. It is a sort of a meaning function, just a more complicated one, and that goes beyond our heads and just goes into the environment. An especially rich and interesting addition is this variable R. So this is the goal of communication, which serves as sort of the center of the active side of this account. And even though Coy does not mention him, it suggests that this might be compatible with the speech act theory by John Austin, as it adds sort of a different and non-verbal motivation, non-linguistic, non-descriptive motivation to the use of signs like speech acts. So now the power and beauty of Coy's approach lies in a very succinct definition of what an event is. And he does it through a number of constraints. The constraints on domains of the variables he gives. Now the first two are pretty boring. This is time in intervals, which is also one of the most controversial ones, I think. But it's not very interesting to describe at this point. Why is it special? It's about the fact that he ties his ontological foundation. He doesn't tie his ontological foundation to a particular cognitive or other phenomenon, physical phenomenon. And that makes his system easier to apply and test with different kinds of operationalizations, which meet these requirements, these simple requirements on the domains of the variable. And you can see some of the more important ones on the slide. So you can look at that the domain of the event that we refer to cannot be the same as the domain of the event that we use to sign. For instance, because, well, the one we use must be observable, because otherwise you wouldn't be able to use it. And it's a series of such simple assumptions that make the theory, and which effectively give you a certain space of possible phenomena that you can use as a foundation for such a system. But you still have to pick it. You still have to naturalize it on your own. It's just a tool that you apply to a certain set of parameters, and you see what happens. And the Coy's promise is that if you can achieve that, if you can find things in the world that fit this description, he will get you a fully fledged semiotic system. Yeah, but it's your job to find them. So now,
4 minutes.
Okay. So now I'm quickly going to talk you through a few of the sort of the flagship topics that any of the philosophical accounts of language need to cover. And that's how signs appear, how they evolve from simple to more complex, and how they are decoded by sign users. So first of all, how they go from simple to more complex. So from sign tokens, the utterances, to sign types. I like this name. Coy calls these signs eternal signs, the sign types, because they retain the mean between users and in opposition to utterances. And an interesting feature of the system is how it explains it in a bottom-up way, which seems a bit more evolutionary plausible. So they start with individual occurrences or of natural signs, and from that emerges the more complicated conventional regular symbol. And it is accomplished for a certain similarity relation on those utterances, on those events. And you can get a taste of this complex character of a symbol versus a natural sign you've seen before by looking at the piece of formalism taken from Coy's book. And this is also why I'm talking only in general terms, because it would take a few hours to get through all of that. So Coy also fits pretty well in the crowd of researchers like ourselves with Joanna, who finds an active approach is convincing. And it is especially visible in Coy's approach to semiogenesis. So he sees it as a sort of dynamical, feedback-rich activity of trying the possibilities opening up in the environment and being attuned to the partner's reaction to those possibilities. So the key intuition behind this process seems to come from the relevance theory. So the idea that we are expected to say certain things that seem most relevant in a particular situation that we find ourselves. So I think it also rings the same bell that we heard in Don's talk, that quote from Stuart Kaufman, that we basically move toward the adjacent possibles. So the adjacent possible here is sort of the needs that we expect the other person to have, and we try to guess them and wait for his reaction if we did it properly. This is just a little curiosity. It's not important for the theory, but I think also that Coy sort of prefigured Levinson's work in semantics, and that he discovered that expectations about how language is normally used are crucial for the symbol creation, for the sign creation in general. So it's also great for philosophy of language, not just for biosemiotics, because it deals in a single system with problematic stuff like metaphors, or irony, lying, fiction. It also reflects in the formalism that these are complex things. As you can see, again, it's an extremely long definition for something that in most philosophical systems takes only a few signs, because there are so many assumptions. He really does the work.
It's max 3 hours.
Yeah. So now a word why I think this is already beginning conclusions, why it is attractive for biosemiotics. As I said before, we start from natural science, and then we get sort of analytically to fundamental. We get systemically to more complex linguistic science. That's one interesting thing. The other one is that we construct a theory that reflects how we see the emergence of science in the wild. So we start with utterances and we go to types, which is also refreshing. And we also, Coy also resorts to measurables, or at least allows us to resort to measurables, but also involves individual phenomenology. So he is perfectly fine with seeing thoughts, for instance, the way that relevance theory sees them. So as sort of linguistic events. They're not a secret language of thoughts or mental representations. They're just part of language. That they are propositions we didn't have time to say yet, but we are going to. They're possible to verbalize, in other words. Yeah. So now is the last bit, and I think the most exciting, and it's not about Coy, it's about Gibson. So here I have this very neat 10-page article in which he proposes to sort of do away with the classical conception of perception, especially perception of space and time, as if there were some sort of independent absolute phenomena that we can measure and relate to in an absolute way. So it is sort of a still Kantian position that the ideas of time and space are given prior to experience. We just have them, we are born with them, and we have to apply them. So he says, no. He argues that ecological psychology has an entirely different answer, and that what perception really does, it's not creating a separate measuring device for particular properties in the world, or even such special ones like time and space. Instead, he proposes that time and space are abstract concepts, and they're theoretical achievements which help us make sense of the events that take place in the world, which are the real foundation for what we see, and at least for perception, even if not for the objective ontology. So this special kind of perceptive events seems like a wonderful and a promising candidate as the basis for the events in the theory of event-based semiotics, the one that Coy developed. They are defined in naturalistic terms of the changing surfaces, and with additional operationalization, they may actually provide a framework for experimental work in semiogenesis if we follow Coy's tool. In humans, at least, and some other animals. I'm not sure if we can go far lower, but it's still pretty satisfying. So to conclude, of course, there are problems to solve with Coy's theory, especially this very brief introduction of time and time intervals, which we don't know yet what to do with it. But he also came up with it at the end of his life, so he didn't have much time to work through problems. But nonetheless, the work he managed to do shows, I think, untapped potential of eventism in biosemiotics and also beyond. So it goes from actual signs or utterances to sign types. It accounts for natural signs and linguistic signs within the same formal framework. It sees abstractions at the very core of sign usage. It allows for individual phenomenal perspective without resorting to mental representations. And its interpretation, the notion of interpretation, is well defined in terms of several classes of events constrained by domains, which do not require sort of a magical conscious component to work. And I think for that bit, Terry's making distinctions that he was talking about yesterday, it may be just enough. Maybe that is that special component. So I believe that events may be the tool to push this, at least the macro life focused branch of biosemantic a bit closer to the scholarly mainstream without compromising too much from its findings. So thanks a lot.
Thank you, Boris and Johanna. Let's take about 5 minutes for questions for this talk. And then after that, we will have an extra 15 minutes or so before we're scheduled to conclude for the day. But for now, questions for Boris and Johanna? Peter, you have your hand up. Is that from last time, or do you have a question now?
No, sorry. That's from last time.
Oh, and before we start, I need to invite you to a conference that's happening online in September. That's my duty. So please come. This is the link. It's going to be fun. It touches on the problems that Tori introduced yesterday. So you should come, Tori.
I will. Tyler or Ludmila, I don't know which one of you has your hand up.
It was me.
Okay.
Congrats, it was a really great presentation. I really liked how you implemented pragmatics, like you referred to John Austin and relevance theory. So is it where the pragmatic turn in linguistics? I had the impression that what you are doing is the pragmatic turn in semiotics. Mm-hmm. So my question is, am I interpreting this correctly? And if so, do you think that biosemiotics is the right way for such a pragmatic turn in semiotics?
Who responds?
I will do one sentence and then you rest.
Great.
So for me, semiotics is very pragmatic compared to other approaches. So making it more pragmatic may be worthwhile, especially in the context of some of the interpretations and presentations which tend to those representational sort of traditional cognitive sciences. I think we should go full-fledged pragmatics, yes. And biosemiotics, I don't see any obstacles.
Yeah, I think it has to be pragmatic, at least with humans. And this is going to be heretical, and Johanna doesn't agree. But I think it has a lot to do with attention. And a lot of Austin's work is actually about directing attention. And that's also a very nice naturalization of a pragmatic approach. And I think it has to be included in biosemiotics.
Well, I do agree. For me, just attention is, how you get there. It's one of the means to get to the real sort of pragmatic and coordinative dynamics that we're trying to explain.
Thank you. Yogi?
Yes. Thank you very much for your presentation. I found it very convincing that, the feature of events with, you could say, dissipative and discrete boundaries in space and time is a crucial insight that is complicated, I think, by the notion of objects coming from an object-oriented ontology. And I even think, you were saying, does this work throughout the kingdom or different kingdoms or different domains. And I think that even with plants, you know, with sort of like calcium ion triggering, that it's once something is received, once a message is received, and reception itself is a form of event rather than necessarily only an object, that it sort of triggers a response, right, or demands a response. And on the other side of things, I just couldn't help but think of the Greek differentiation between chronos and kairos, right? Whereas kairos is an event-based theory of time, and chronos is a discrete clock. Is sort of, it's an artifact, is artificially created, just like a piano artificially divides half steps.
I think that's a nice point, and it very well fits into not only into Coy, because I don't think he has time to think about those things, but I mean in the book, but to Gibson. I think this is exactly what Gibson means. That's you know, we have some abstract time that we invented to, you know, make sense of the world, but it doesn't really mean that this is the thing we perceive. It just makes it easier. And I also a little addendum. I'm sure it's pretty obvious, but I want to make it clear. You still have objects. You can have objects with event-based ontology because objects are important. We want objects. We just don't want them to be the only thing in the world. And the traditional way to have objects in event ontologies that comes from Bowers and Perry and Creswell also is such sequences of events in time, which have a different relation of similarity going on there. Yeah.
It's just so exciting that you know, you can get a little bit closer to something dynamic with a sign itself, sign vehicle, even just like Michael was showing in the previous presentation. But it still does not solve the problem of how you can look at such a bunch of events and make a quasi-generative system or computational system out of it. But it might be, it sort of gets us closer because it makes us understand how hard it is and how important the relations are, for example, which may be the way, right? Okay.
Josh?
Yeah, can you hear me?
Yeah.
Okay. Yeah, that was, I really enjoyed that presentation. I like the move a lot to, or at least being inclusive of event-based, time-based, but still with time-based, and I'm just echoing, you know, Johanna's concerns about how it is, you essentially, you have relevance, what is relevant, but then the adjacent possible, how do new relevancies emerge? And how do you move your attention from, you know, the metastability of being in a stable attentional state to another attentional state? Like, how do we begin to explain that? You know, for example, like a time, you know, we're in your event-based, you know, system where it's time-based, you have, say, an integral where you still have to choose your time. You still have to choose, you know, the bounds of the integral in order to compute it. Those are still choices that are imposed from the outside. Is there anything in this model that you're proposing that those kinds of things, you know, you have something in a very short time that's subsumed into something that's still causal in a longer time, like how those superpose to co-occur and co-affect each other? Is that addressed in the analytical model?
I start and I am not sure because this Leon Coy is our recent discovery, and we are just excited about it because it gives us language to talk to sort of other people also, and it's very important. But what you are talking about, the problematic notion of sort of time intervals, I think can partly be solved by Gibson, who says that all time is eventual, so, or event-based. So actually what you have to solve your integral interval might be an action selection, that you have only one body in which you can only with which you can make only limited time of actions in the same moment, and those can be actually something that sort of chops your events, and that actually there is a very important notion there coming from the possibility of multiple actions to an actuality of a performed action. And I would think that this probably would be the ways to go through Gibson. That's why Gibson is such a nice addendum to this, to COI, and to go through Gibson and actually through more action-based approach, because action and this extreme pragmatics actually gives you the realizations of concrete periods of time. Somehow sounds also compatible with Susan Langer or Stern, or the action arcs, but that's another story.
Thank you. I want to go to Philip now, and I also want to say too that we can open this up to a larger discussion now. I know, Philip, you also had a question from the previous talk that you didn't get to ask. So if you want to, follow up with Boris and Johanna now, and then ask your other question.
Can we?
Yeah, that's about exactly what I want to do. First, I want to do something that Peter Harris Jones has done and say, well, Gregory Bateson, and what is remarkable to me is that, rightly understood, I think he's an event theorist throughout, and that he's always an event theorist. And if you go back to my talk about play, you're talking about the nip and the fight, but both of these are events. They are not objects. And I notice that when I think about icon, I worry a lot about icon and index and so on, and they look different from an event perspective than they do from an object perspective. And especially iconism, I think, looks very different from an event perspective than from an object perspective. And I don't know how that would change some of our evolutionary theories about which comes first or in what order, or how these play themselves out in non-linguistic evolution of or non-linguistic non-evolution of the sign. And somewhat distantly related to my question with Michael Jacob Parham and Terence Deacon is is at the end, they were talking about the iconic resonance in the brain. And what I wondered there, again, dealing with all these icon index questions that are swirling around in my brain, is there any sense of, or is there any act of comparison that happens in this iconic resonance? That's my question for that talk.
Who's going first?
Boris, you wanted to answer?
I don't really get it. Iconic resonance.
No. With the
other one.
But I think the first one was the comment, right?
Yeah, the first one was mostly comment. It's just basically saying that I think that Gregory Bateson's approach is very much involved with event, and that event is going to be very helpful, and especially it will change our attitude toward icon and index.
Yes, and it gives, I wanted to just add that it gives so much more dimensions on which something can be iconic. Also the dynamical attractors, for example, for one thing, to make the connection. But also what I wanted to add is that I do have problems even with the name, with the word event, because I think event is something very sort of observable from outside. I would rather go with Merleau-Ponty for engagements, because somehow we are always implicated in the events, and those events are interesting in which we are implicated. So I would just try to include even more enactivism, even more experience in the notion of events. I don't know if Bateson, that's a question to you.
Yeah, yes, I would say yes. He might correct me in exactly the direction that you are, because that's always, you know, the observer, if you want to use the old cybernetic lingo, is always involved. And so he would go to the blackboard and say, you know, you don't perceive. He would draw a little dot, and then he would run his finger, and he said that you know, you always have to make, you don't see an object, you always run your finger across, and then you might feel that little raised bit on the blackboard, but you're always making into an event, or micronystagmus in the case of vision. You're taking what you might think of as a perception of something static, but you are always making it into an event. But then you are also in there. So it's both the correction into event theory, but also into the implication of, you know, you are involved in it too. Yeah. Yeah.
Technically, I'm not moderating now since this is open discussion, but Don did have his hand up, and I have a question for Peter too. Philip, are you finished? Because you did have another thing that
I want an answer from someone from the previous talk about the dynamic, what was it? Iconic resonance. Is iconic resonance just a resemblance that does not involve an act of comparison, or is there somewhere an act of comparison by something in that process?
Yeah, I'll jump in, then I'm sure Terry will probably have something to add, but I think that there is an active comparison implied by the model. And as we've sort of hypothetically conceived that process might actually occur between separate populations, for example, or brain regions that have their own particular dynamical trajectories that are in connection, directly, physically connected, of course, but then in dynamic space, they may also be engaged in a comparison of their trajectories.
I'll add to that very quickly, and that simply is a way to say that whenever two complex dynamical patterns are juxtaposed with respect to each other, even though one may have triggered the other, like in a standard resonance notion in sound. We're talking about, of course, something with more dimensionality than that. But nevertheless, there's also the dissonance. And the dissonance itself is about what's not the same. So there's the what's the same and what's not the same are both there. Presumably, since these systems within the brain are multiply linked to each other, obviously what's going to happen is that dissonance is going to be picked up somewhere else. And the question is whether that dissonance is enough to drive a change in activity, to shift the focus of attention, so to speak, to another feature of the stimulus or not. That in some cases we ignore it. They're similar enough. Our pragmatic interests are minimal in terms of that difference. Therefore, the difference is ignored. And of course, we're much more familiar with many examples where drastic differences can be ignored, not seen, not rising to awareness. We're very commonly aware of that. And that's partly because those dissonances simply just get lost. They get buried. So I think it's obviously more complicated than just a simple kind of resonance idea. And that has to do with the fact that, just like if two people are playing the same, playing their music, sometimes, the two CDs are playing and they're conflicting with each other, sometimes together, sometimes not. Or musicians are jamming together, sometimes much closer, sometimes much further apart. Again, the problem with iconicity is that there are not discrete boundaries. There's more and less. And as a result, there can be sort of thresholds. We can ignore the differences or not.
If we have a minute later, I can show a visual auditory example of this, just a short 30-second clip, but we can save that for the end. I don't want to interrupt the flow here either.
You can do it now.
Oh.
All right. So let me just, I'll share this as a quick clip. A colleague of mine put together, who's in Amsterdam. Let me make sure I'm sharing the, share the sound. Don't think Terry's had a chance to see this yet, but just, it's pretty short. There's going to be two attractors that actually come together. And for the first attractor, the change in time is mapped to the metronome for a series of arpeggios. So it'll play at the same rate. And then the second attractor to the metronome controls the rotation of a random walk generator that plays parallel thirds. So arpeggios in one attractor, parallel thirds in another, just to get a sense of maybe the way these, this is, I think, a little bit more the consonants that Terry was describing. So that's the first attractor. So the idea of resonance here is really just based on the shared form of two Lorenz attractors, and you can kind of have to imagine for yourself a totally different shaped attractor coming in playing a melody that just doesn't fit at all, and how that might be might draw your attention, or as Terry's suggesting, may just never come to your attention because it's just not relevant to the action space that you're currently engaged in.
Don, do you finally want to say something, and then?
Okay, I'll jump backwards. Although I'm beginning to see why you could think of that as a signed vehicle. Right, but we won't go into that right now. This is I want to follow up on Philip's comment, and I also want to Boris and Joanna in particular to think of this, but everyone, because I wouldn't push it if I didn't think it was a deep framework worth looking at. Peirce's entire project, why he called it originally pragmatism and then pragmaticism, is only and always about action opportunities and events. His maxim is, consider what effects that might conceivably have practical bearings, that we conceive the so-called object of our conception, not the thing itself, to have. Then our object of these effects is our whole conception of the object. For Peirce, and I think there's a quote by Bateson, I don't have it off the top of my head, I learned it from Jesper, Peter or Philip will know it. Bateson says something somewhere like, the smallest unit of communication is the whole message, right? Similarly, there's a good way of reading Peirce, I think Frederick Sternfeld came up with this many years ago, that there is the event, right? There's the thirdness, there's the practice, there's a set of practical bearings, which is the meaning of the sign. And from that, from those effects it might have, we derive things or icons, and we derive relations. We prescind them from our experience of effects in the world, right? So I want to make the case that Peirce is, to my knowledge still, the premier event process theorist, because when you read Peirce, at least in the way I read Peirce, this is all that it's about. And again, icons and indexes are secondary only because they come from the thirdness relation of action of an agent in the world, right? So Peircean semiotics, I think, holds what a lot of people are looking for when they want it. Again, if you think that it starts with an object and it starts with a representation, that's not Peircean semiotics at all. That's in a very limited case, but the object is always a derivation of activity in the world. And what it's always directed to is practical bearings or action opportunities, just as in Gibson, just as in activism. And they are the things surrounding us that we are attending to with our perceptual apparatus, and they are signs. So I'll leave the preaching at that.
I think we suspected that all along, but this only shows you how misinterpreted pairs often is, especially, you know, it's so easy to fall into the trap of thinking of symbols as something abstract, somehow discrete, and forgetting that they are actually vehicles which are extended in time, right? And then, okay, we then making the step. I mean, the guy wrote the whole book about this, so it means that. And I think he also read his pairs. It's not that you know, but he read it in the 90s probably, and therefore when the computationalism was on its probably apex, I hope it's declining slowly now, but you know, this was a strong reaction, and I think, you know, somebody would say, okay, we are shooting ourselves in the knee because now we are saying that everything is continuous and how we get out of it. But Peirce said it all along. I agree.
Yeah.
I agree.
As you say, symbols are relation. They're an orientation we have towards things that are built out of relations. But when I saw the equations, the Z, T, R, P, what it reminded me of was Charles Morris, who was a student of Peirce. And Morris wanted to make Peirce more scientific, and he wanted to specify, you know, things like context and things like, you know, what's the difference between the definition of a sign and the, you know, referent of a sign. So I see the same type of impetus going on in this work. And my last question is type of question I'm always interested in. Will there be English translations of this work? Or Boris, would you undertake one?
If you publish it, I can translate.
Call me at the Biosemiotics book series. We'll talk.
All right.
I want to ask Peter Cariani something from his talk before we complete for the day. Peter, are you still there? Yeah, there you are. So, you know, the example that you gave with PASC of, you know, a cybernetic system or chemical system developing new ways to sense things in the environment, and you know, this is on its way to being a semiotic system. I believe you said that you think that a cybernetic system is capable of semiosis. Is a cybernetic system such as PASC constructed? It can develop new tools for sensing things in its environment, but for what purpose? Can it develop those tools to be able to, you know, prolong its survival, or, you know, does it have goals other than just creating tools for the sake of creating tools? They may be self-perpetuating, or.
I mean, PASC device, the goals were not built in and embedded, but you know, just like a thermostat, you could have some sort of electrochemical assemblage that's sensitive to 2 frequencies of sound, and it switches something else. You know, an earlier installation of PASC was Musicolor, and it was doing light shows in response to music. The point of the PASC electrochemical device, that doesn't have a purpose in and of itself. It was steered and rewarded whenever it changed its conductivity with respect to something that was going on in the environment. But it's the same situation that organisms, you know, lineage of organisms, and they're evolving a new sensory capability. They don't know a priori that there's some perturbation in the environment that might help them survive. But if you have, again, selection and survival and inheritance, you can evolve systems that will come to construct those sorts of sensory organs. So I would say that the PASC device has some semantics, some emergent semantics, but it doesn't really have pragmatics because it's not connected to an internal goal-seeking system. you could connect it to one, and then you would have an agent that seeks out sensors that are useful for some purpose, like sniffing out landmines or something, or detecting disease of one sort or another. All these ill-defined problems where you don't know what are the sensors that you need, you can harness them to a goal-seeking system and have there be feedback to structure that then evolves the sensors. Maybe, I'm sorry that's so long-winded, but pass device is one of the very few technologies that in which you have sort of evolvable sensors. And as I mentioned, in the last 10 years, there are these convolutional networks that sort of do that by changing filters and input representations. But past example is really the most salient one.
It's a nice representation. I just wonder if we have any examples yet of machines evolving new purposes for themselves and that the designers didn't have in mind. I am stepping back as moderator now, and I want to let everybody know that the discussion is officially a free-for-all. Please go for it, anyone.
Yes, please. Am I on?
Couldn't Parham Portavoort say a word? Because Parham Portavoort.
Olivia, that's a great idea. We want to hear from Parham. It's going to be open now. We've got another half hour free, but Peter was in the middle of a question. And then everyone who has their hands raised can put them down and just jump in for free at this point. So Peter and then Parham.
Okay, I hope I'm not taking up too much time. I just wanted to introduce historical mode.
Sound drop.
I removed my mute here.
It's a bad connection, I think, Peter.
What have I done? Yeah?
Yeah, back again.
No, it's a bad connection. Make a historical note here about the pragmatic connections and moving over to Gibson. And this is food for thought because we are biosemiotics. That Bateson went for the first and only time in his life berserk when Watzlawick, Bevan and Jackson published a set of lectures that he gave and called it the pragmatics of communication. And he explained quite clearly it was not to move necessarily towards the Gibson approach, which others might do, that he wanted to move to a greater gestalt with the notion of semiotics. So I think we're engaged in two-way semiotics. If we improve our pragmatism, I think we must also try and follow his other path, because ecosystem connection and understanding semiotics as an ecosystem is a matter of existence today, as far as I'm concerned. Future existence, that is, not along with biosemiotics, which is there.
Yeah. I would add to that the very concept of pragmatism is, of course, a theory of value. And a theory of value has to have beneficiaries or harm associated with it. And as a result, taking an externalist perspective that misses beneficiary and harm, misses the concept of self, always leaves pragmatism out. It's not just about what persists, but something that acts in order to persist, acts in order to adapt. So I think critically, one of the issues is that when we talk about systems in the absence of talking about being, doing work to be, to continue to exist, we're leaving out that sort of critical pragmatic element. And this is why when we talk about things like affordance, it's affordance for something, to accomplish something. That the goals are not just states, the goals have to do with persistence and existence and benefit.
Can I jump in and ask a question to Michael, Terry, and Parham? Do you see any way your attractors can be not can be compositional, but maybe account for compositionality?
So let me just very quickly, I mean, I can't go through the presentation about this, but
Terry, you're muted.
Oh, I didn't think I was, but let me see.
I can hear you.
Okay. And this Michael just very briefly mentioned this, and I cannot go through it. This notion of countercurrent processing within the cerebral cortex, something I've been interested in for about 30 years now. And this has to do with the fact that different subregions of a sensory system, particularly in large cortex mammals, fractionate a sensory input. And that means that there are different aspects that are being focused on. And yet, our experience, of course, is one holistic perception. That doesn't mean that all these aspects aren't there, but that does mean that we can now, in a sense, focus in on you might say prioritize one feature, one dimensionality or another, whether in vision, it might be movement or color or edges, the variety of things that can be there. The problem is that particularly in animals like ourselves with many, many cortical areas, that is fractionated and run in parallel. And one of the great challenges and one of the anatomical interests that I have is how these fractionated perceptions are a single perception. How are they brought together? This is the attentional question that we've been sort of talking around in various ways. The whole point of this, however, is that iconism is itself a concept about similarity, and similarity is not about identity. Similarity is about, resonance is an example of a kind of similarity relationship, a very simple one, but similarity can be fractionated. And this goes back to the Gibsonian perspective in that a particular percept or particular event has many features. And there's some that are affordances that we utilize for some purpose and others that we ignore. It doesn't mean that we're not analyzing many, many at once, but it means that only some of them come to the fore. I don't know if that quite answers the question, but the whole idea is that perception is also, it's fractionated and whole at the same time.
Can I get in?
Yeah, everyone just speak up. Nobody's sharing.
Oh, that's
like at the bar.
So it's not exactly on the topic of the question, but it's on your talk. So first of all, I must say I am very upset about your talk because I was writing a grant application recently and I was very proud of myself. I invented the term neurosemiotics, and now this conference you give this.
I should add that there's a book coming out.
Yeah. At least I want to be mentioned, like the third guy who came up with it.
No, that was a long time ago.
Yeah, a long time ago.
But I was wondering, because I mean, the reason that I came up with the term is I was thinking about some experimental stuff you can do to measure similar, well, not exactly what you do, but some brain activities connected to some processes you can call semiosis under certain conditions. And, I'm still trying to design it, but a PhD, graduate now of Stefan Harnaz was helping me to operationalize the problem and actually put people into an fMRI machine. And I was wondering, are you open to this sort of stuff? Would you like to get it, have a chat, or are you just, you want a model? That's enough. This is too.
No. It's please.
Yeah, I can jump in here.
Quite open.
Yeah, we are very much oriented. Actually, my background is in experimental work, and frankly, I think I'm a poor modeler on some level. I kind of just try and put it together as the best I can. But experimentally, it's my experience working with both, animals and in human sub participants that this is what's going on. And a small comment, be really interested, getting back to this idea of events. So much of the field of neuroscience, and this may have some relationship, I think, to your talk, is geared around this idea of event-related phenomena. And I think that their idea of what the event is and at what point in time to then record all of the activity going forward and ignore the activity before, or to average it from that point in time going forward is problematic, clearly. But also, I think, and we have an interest in this because of trying to look at sort of the ongoing activity, like where's the event in the ongoing stream. And so I'd be very interested in having a conversation about what is setting the context for an event in terms of the gradual flow of the ongoing activity or experience, and how that interacts with events. So there's, I think, a lot of potential great dialogue here.
In my own model, the way I try to struggle and provisionally provide a hypothesis, at least that and to Johanna, we had an email a ways back. You asked me what this technical object I was proposing, and that was essentially the schematic design that I showed in my talk. And the idea being that each node, each primary node is enacting, if you will, and that it's necessary for each node, once it's sort of reached its criticality, once it's reached a threshold of stimulation, and again, all that has to be empirically figured out, such that there's a balance between each individual emoting, for lack of a better term, into the interstitial space, and that interference pattern essentially is the necessary piece that then all the other elements that are simultaneously emoting, and this is the problem. I think the event-based, there needs to be some way that the event is rising above the noise floor and that it can scale, right? So that we have this balance between, as Simondon talks about, in individuation, how it is you have simultaneously distinctness and interrelation, such that in the interference pattern, as I talked about in my talk, each individual pattern superposes with other patterns to generate new dimensions, to generate more complex patterns that then, even though they're ephemeral, they can be sensed and then be fed back in as constraints on subsequent action, so that it can scale. And then in principle, in theory, you have these higher order patterns, this sparse order, if you will, in the structured noise, rising above the noise floor. And that, given some kind of limited power supply, limited current, as the order accrues, sort of the criticality accrues, it sucks current from the available power for the noise. And so the noise floor drops as the so-called signal, if you will. It's not quite a sign yet, let's say, but it's certainly growing to be a signal. And then when there's enough of a signal, ideally you will have designed a system, or it will have evolved to find that perfect balance to be sensitive to that sparse order, that now is a higher order, meaning that it's both a combination of the individual diversely tuned nodes and their superposition, so that their higher order pattern has risen above the noise floor to then affect how it is the structure is literally informed, such that new structure, as I think Jagmar really nicely talked about with Simondon, how it is, operation is always going, it's always processual, but how does structure emerge out of the process? It's not really sequential. I mean, sequential things happen. It's not saying that there isn't a sequence of events, but how is it the sequence of events become adaptive, become relevant to their environment? How do those structures emerge to constrain subsequent operations and vice versa?
I think just to jump in a little bit, linking the Michael's also previous comment. Simondon and individuation and sort of local coherence within some time horizons, I think, are basically the way to go. And also it links so nice with your comment about ERPs, which are event-related potential. So what events? I mean, they are trying to make stimuli. And Gibson was laughing in his, I think 1960 paper. He wrote a paper about a stimulus. What is a stimulus? There is no such thing as a stimulus. I mean, you create them artificially by repeating something many times. It's not an event. So I leave open the question, how come these things we engage in become adaptive, or are adaptive rather, for later. But I wanted to sort of not to let Michael off the hook about the compositionality question, because I think that Terry did not, I mean, I don't think there is the answer, but maybe you want to rebuke the question, because the compositionality becomes a stupid concept because it almost always means trivial compositionality. While we have in our sort of ontology, we have emergence as a sort of next level of complexity. And I just wanted to, before we return to your question, Josh, I wanted to ask Michael about this.
Answer.
That's what I was going to say. Parham hasn't had a chance to speak up, and Parham, why don't you jump in if you have a thought about the entirety of the composition and maybe the use of that term, thinking about.
Yeah. Give the hard questions to your students.
Yeah, exactly.
Elaborate what you mean by that when it comes to attractors? What do you mean by compositionality?
Well, the sort of traditional notion of compositionality is that you can sort of have semantic compositionality, like, I don't know, having the notion blue and the notion round, and then, playing with those. So you have a blue ball and then yellow ball and then blue triangle or whatever. And this is trivial compositionality, which obviously has nothing to do with how language does it. Because the minute you use two words, they become a relation between the two words, and it's really. But you are talking about attractors and vehicles having some sort of dynamical attractors, and you can have relation between dynamical attractors. So that's the question about how the compositionality looks like within your system.
A brief historical comment for this handbook of neurosemiotics. We made a historical overview of neurosemiotics and discovered that the term was used already in 1969. So, and in 70s already several times. So that's a really old concept. But here, I think that today's session even about neurosemiotics is really, really fascinating. And now in the context of biosemiotics, to speak about brain, I think here additional sort of aspects should be maybe paid attention to. That's namely this, that always when people are speaking, either philosophers or neurobiologists or many other on brain, say they actually very often speak about those features of the brain which exist also in other heterogeneous tissues, living tissues. Say, and mainly now, I think in our community, it is, I think, very important now to see when we are speaking about general semiotic processes, semiosis, so which do not require neural tissue. So then what are namely those features when they, well, speaking about now yeah, on the neurobiology, which are necessary in these models, in addition to usual, let's say, many other tissues which are not built on neurons. That's even, I think, Peter Cariani's models there, often it's not seen what's necessarily coming from, namely from neural.
Right. Biosemiotics is not going to advance the notion that signs start with the brain, right? In other words, the sign relationship is at play in much, much simpler brainless organisms. So if we're going to have a model of a sign relationship, whatever's happening on that lower level, in some sense, has to be at least the basics of what we're going to find up at the higher level. And here, once again, I'd like to recommend, it's very interesting the way Josh and Peter and Michael and everyone are talking about the resonances within the brain, within the system. But we also must remember the perturbations from outside the system are part of the sign. This is what semiotic realism is. Those attractors are the certain way, not only because of the biology of the organism, but because of the environment that is perturbing it at the time. And so if you think of it this way, you really start to ask Kalevi's question, what is it we look for that overlaps this way, whether neuronally or whether, say, in a community of interacting single cellular organisms exchanging chemical messages, right? Is there some formal model we can come up with that covers all of these instances? And you know, that's the great big project.
I think
we won't live to see, but it's a project, I think.
Yeah, I think one way to
give a quick
connect I think one way to connect those. I think one way to connect those dots is I became, well, in 2018, in my 2018 biosemiotics talk, in order to bridge the gap, because in my talk, I went from people to neurons down to these oscillators, which it doesn't quite maybe answer the question that Kalevi and you were proposing, but then there was interesting model, the Kiramoto model, looking at chemical oscillators, like a diverse population of chemical oscillators in amoeba, as a way to try and bridge that gap. I mean, because there is a gap, right? Where the project still needs to be done, and I would argue that that's a way for iconicity to be understood, both empirically in amoeba and in terms of a model. The Kiramoto model is 30, 40 years old. And then actually Johanna has been pointing me in an activist direction. I think Kelso has done some really great work on going the next step to indexicality. Like, how do you go from iconicity, like these stabilities, like the ability for an amoeba to internalize periodicity, the external, from the external environment. And then Kelso is then looking at his model with his colleagues on indexicality, like how you get metastability, how you get diverse, this gets the individuation question of how it is you have diverse internalizations that are then somehow associated.
Gary?
So let me just quickly say that what we're looking at in the nervous system, or in my own interest, also looking at it in something as simple as a virus. So we're looking not at signs, but we're looking at the generation of interpretants. But when we say an attractor, right? Or I'm looking at so it's a sign process as well, but it's a sign generated to interpret something else.
That's all signs.
Yes, it's all signs, but I want to be clear that one is generated actively, one may be just passively in the world, an affordance in the world that something internally is generated to utilize that affordance for some other purpose. So when we're talking about the central nervous system, I think if you want a language that we want to use, we want to say that we're talking about the generation of interpretants. And those interpretants may be many. They are oftentimes compositional in the sense that we've been talking about. They may build up and build up and build up. So that a scaffolding logic is the next one that you, I'm sure, are very familiar with, and Kelly, of course, that we date back to Jesper's work. This idea that in effect in the nervous system, we're talking about a highly scaffolded system of interpretant generation that requires cells that themselves are generating things. Individual neurons need to be understood in their own semiotic world, as does their internal dynamics, their chemical dynamics. A whole series of steps all the way up. And yet in each case, I think we can use the concept of an interpretant. That is, that unit is generating some dynamical result.
I absolutely agree. Yeah, I absolutely agree, Terry.
I think we're there, but the question is, we don't want to stop at the nervous system, and we don't want to stop at the biochemical level, but we need to understand the scaffolding hierarchy that leads from the bottom on up. And then outside of that, of course, into language and cultural processes. That is, they're linked together all the way up and down, and that's the power of biosemiotics, it seems to me.
I'd like to add a slightly different frame of reference. This is Jamie Rose, in agreement with what Don and Josh were saying, and Terry too, but humanity is built as a biological entity over tens of thousands, 100,000 years of a certain frame of reference, a certain pace of access to the information we're exposed to. The new electronic information age is presenting us with something totally different. We used to be able to have evolution and advancement by producing new offspring who could adapt to and could explore the different possibilities of generating new ways, new neurologies, and individuals that might find different ways of dealing with the information experience, the information environment. We don't have that anymore. We're now in an area where every individual has to adapt on the fly immediately. And we're not sure whether we have the innate neurology and abilities that is built up with the potential to explore them individually and to expand upon them and to improve upon them, where we can then pass that along to new generations or not, but we have to do it on the fly. And so the notion of information overload was just a key alert to us that this is now something that we have to adapt to during each individual lifetime. So the competence to handle many sources of information competently and multiplicity it's something that no living creature has ever experienced in evolution on our planet. And yet this is where we are as a new species, and something that we have to be prepared for, and to change our educational process, change the way we teach, change the way the information what we expose our children to, the pacings of how we expose our children to them, because in order to build that future confidence, it's looking deeper into the biophysiology and the neurology is all well and good, but we have to do it as a real-time practice on the fly immediately now. And that's just a slightly different change of perspective that living creatures are being challenged with. Wow, silence. Okay.
No, just anyone want to reply to that? Is Nora here? I think Nora is a good person
it's the new pragmatism. That is,
well, that's it, right?
Well, clearly we are a global species at risk of destroying ourselves and much of the rest of the planet. There's a benefit and a risk problem here. This is a new level of pragmatism that our species, I think James is quite right.
Okay, well, have we actually got to the point where everyone, yeah, please, anyone who wants to come in?
I just want to say, I think that was Bates' message, although he didn't have a long enough time really to express it, going along, and nobody reacting to it seemed to react to it. I'm sorry to make all these Bateson references, but it is a Bateson conference. And you invited me in, so it's your problem.
This is what we want. We want Bateson, we want Peirce, we want theorists we haven't heard of. This is exactly what we want. Anyone want to say anything else before we close for the night?
Can we make it? Whoa. Sorry.
Okay, go ahead.
Yeah, but now it's not going to be funny. I wanted to ask for a gong bath to be part of the next Biosemiotics conference.
A gong bath?
Would that be all right?
A gong bath, okay. we'll see if we
all
can
in the
work
chat.
that in. All right. All right, everyone. Thank you for coming again. It's been another great night. And tomorrow, too soon, we come to the end of it. Daniel, while you're here, can I ask you, is the day 2 up yet?
Sorry, again?
Is day 2's video up yet?
It's on its way up
rendering?
tonight. Tonight, it's quite big, so we had to blur the... So it's coming up tonight.
Okay. And day 3 will be up soon, or it's up now? Day 3 goes up also soon, yeah?
Yeah, it's here.
Excellent. Thank you, Daniel. Thank you very much. Thank you all. Tori, thank you for sharing. Thanks to all of our presenters. Thanks to all of our viewers. Just thank the whole damn thing. Okay, see you guys tomorrow.
Thank you.
Yeah.
Good night, everyone.
Good night, everyone.
We have a feeling of a real conference. I don't know about you guys, but I hope you do too.
Get in there.
It worked out really.
Something great
It is real.
Nothing could be more real. Good night, everyone.
Virtually real.
It's virtually real.
Ciao.
Ciao.
See you tomorrow.